Okay, thank you. Thank you. Yeah. Good morning. So, Maria, did you sleep well last night? Sure? Let's see after lunch, okay? Yeah. Yeah, because I noticed that you're a little bit. Okay, okay. Yeah. So, good morning, everybody. Hopefully, you had a nice time. Uh, Before we start, does anybody have any question, concern, comments regarding the introduction, what we discussed yesterday? Or probably you're going to ask any question? No? Okay, good. So today we are going to talk about distributed energy sources. So we talk about the introduction of the course, that why do we need this small scale energy sources and what is the benefit. So what was the history of the energy technology, what kind of technology we had up to 2000, and what kind of new technology do we need after 2000. So if I'm going to get back to yesterday, so just can you say that, uh, what is the benefit of this type of a small scale energy sources for our society? What is the benefit of this distributed generation technology or a small scale uh, power generation in power and energy society?
We can have like variable power supply.
We can have
A variable power supply.
renewable, you means that. So because variable power supply means that something, the frequency and voltage is not matched with the, so it's like a disturbance.
Means we can like adjust the power based on the requirement of the user.
Yes, very good. Abby, Abby, if I'm not wrong, you must buy chocolate, okay? Next session. I will pay it. No, I'm joking, okay? Don't worry. Don't get stressed. I was in a class and I said that, okay, you had the, I mean, in Finland, the problem is that I said that, when you make the joke, you should say, I'm joking, otherwise it's serious. Doesn't matter what kind of actually joke you are saying. So, uh, one of the students came to my class and I said, okay, you had delay, you must buy the chocolate. And I didn't say, I'm joking. And he was absent next session and the other session. And after 3 sessions, I told his friend that, do you know this gentleman? He said, yes. Tell him I'm joking, okay? So please come back. So I'm joking, okay? So anyway, so it means that we can use the local generation, make the balance between generation and consumption. So it means that we can compensate the part which we have the more consumption due to the more industrial sector added to the network and also the population increase. So then Arya is going to say that, what kind of benefit it brings, like an economical benefit. So
Cost effective.
cost effective. But why it is cost effective?
Because we are not using a large area, and like whatever the
Large
is
area.
generated,
Hmm.
it is just close enough
Yeah,
to
exactly.
the source.
Yeah. Yeah, it means that we don't need to make the new transmission and distribution line. Am I right?
Yes.
Yes. Okay. And what kind of environmental actually benefit? Your name was Navina. Yeah. Navina is going to.
Distributed energy sources are renewable and
Yes.
so they are environmental friendly.
Yes. It's environmental friendly. It reduces the greenhouse gas emissions, and this type of actually a benefit it has. But now, Somi, where are you? Somi, yeah? Somi? sum is. Did you check sum is equal to? Yeah, okay. So what kind of problem it can be appeared in our network by high penetration of a small scale renewable energies?
Mismatch in the inertia.
Mhm. Yes, yeah, it makes some problem. For example, this type of technology cannot provide the inertia. Then, with high penetration of such a converter-based generator, um, we somehow threatening some stability of the power grid. So, excellent. Now we are going to talk, when we said that, I mean, from now we said DG instead of distributed generation, okay? When we talk about the DG, what kind of sources are considered as a DG? So the learning outcome of this session will be, at the end of this chapter, you will be able to identify different types of the actually available DG sources in power and energy sectors and explain different topologies for such cases. So, when we are talking about the small scale renewable or energy sources, what does it mean? Can you give me one example? A smaller scale. Battery. PV. Yeah, exactly. Local PV generation. So you can install local PV generation, PV in roof, and then you provide electricity. But when we are talking about DG technology, it doesn't mean renewable only. So if you have a diesel generator, it can provide electricity for your home, and then it can be considered as a DG source. So basically, DG sources are defined for the sources between 1 kilowatt up to 10 megawatt. Okay? So after 10 megawatt, we consider as a power plant. So when we are talking about the DG, first assumption is the power we have or they are available is between 1 kilowatt up to 10 megawatt. So a small battery can be considered as a DG, and also one solar farm which provide support for the distribution company based on the forecast also can be considered as a DG. So there is a video here, but later I don't know. It's normally doesn't work. Seems that's working. No. Okay.
In a conventional power system,
It doesn't
in a
have
conventional
any.
power system, the generation of electricity is concentrated in a few power stations.
Hmm?
In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The
Can you hear?
development of future electrical systems will be based on the complementarity between In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption.
So. What this one? If I use probably let's try. Yeah.
consumption
You're
is an
praising.
improvement for the environment and energy consumption, since there will be less power lost during the transportation of electricity. Efficiency of the distributed generation system also reduces economic costs and fosters the development
Fix this mic
Mhm.
on this side and keep this on.
in a conventional power system. The generation of electricity is concentrated in a few power stations. Distributed generation also merged as an alternative model to the traditional one.
Is yeah.
This new model brings generation closer to consumers. The
It won't work. Yeah. Can you come? Kanji? Vijay? Something.
Well, it's fine. Actually, later they can change. It's not something complicated, okay? So you can follow with teaching material.
Okay.
Yeah. Yes.
Yeah. Video ఒక run చేయ.
Voltage. I mean, no, this is kilo. Yeah. Yeah, for. I mean voltage because this is it doesn't have any specific application, so it just follow the reference we have, a standard we have in this network. If you are going to deal with the distribution grid, so it can be 400 volt or 20 kilowatt. Then for example for high voltage, it doesn't make sense because this type of technology is just for distribution level, not for transmission level. Yeah. No. Yeah. Because there is no classification for this type of generation also. Yeah. I can hear, but why you are pretending to say that we are not hearing?
Okay.
Yeah.
Here, can you link it? Yeah. When you were left. Okay.
Yeah. It's because of the area. Yeah. It's very problematic. So let me. Yeah. Give it to.
Yeah, now you can play.
They just. Yeah.
In a conventional power system, the
Thank you.
generation of
Thank you.
electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption is an improvement for the environment and energy consumption, since there will be less power lost during the transportation of electricity. The efficiency of the distributed generation system also reduces economic costs and fosters the development of renewable energy. Distributed generation is based on the following energy sources: solar panels on the roof of buildings and homes, isolated wind turbines, which are usually a good complement to solar power, electric cars that can connect to the grid to both provide and consume electricity.
So let's get back again to this.
In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption is an improvement for the environment and energy consumption, since there will be less power lost during the transportation of electricity. The efficiency of the distributed generation system reduces economic costs and fosters the development of renewable energy. Distributed generation is based on the following energy sources: solar panels on the roof of buildings and homes, isolated wind turbines, which are usually a good complement to solar power, electric cars that can connect to the grid to both provide and consume electricity. With distributed generation, electricity demand at peak times can be optimized. It also improves service in rural areas that are a distance from the power grid and in urban areas where the grid is overloaded.
So, she said that it can increase the efficiency, and it cannot be, I mean, it was not existed in conventional power grid. Why? Because the conventional power grid are somehow passive. And then the other problem is that, or benefit is that it has an economical benefit, but if you mention, they said that wind, solar, electric vehicles, so electric vehicle can be also one of them. Why? Because we have the battery. Does anybody has any idea about the capacity of the battery? For example, Tesla, 40, 2.5, no. Any other idea?
You are talking about the vehicle battery, right?
Yes,
I think 40 to 80. I have heard.
40 to 80. So it's a long, actually, difference between 40 and 80.
So it depends on the range as well, right?
Yeah.
Now in India, if you study this
Mhm.
conditions, so accordingly, the average size of battery in Indian electric vehicles is 40 kilowatt hours.
Okay. Yeah, probably this is because of the different vehicles, but for example, Tesla S6 model is up to 120, 30, something like kilowatt. Okay, so it can be very good potential when we allocate this type of technology when we have the peak demand. So when the stress over the grid is somehow very high, then you can use this one as a source of distributed generation to support the grid and reduce the stress over the grid. So it doesn't mean that you need to just inject power to the grid. So assuming that you have actually such a potential in your buildings, so you can actually discharge electricity from the battery and provide electricity for your own load. So by this, you somehow isolate your system from the grid, your load from the grid. By this, you reduce stress over the grid. So there are two benefits for such cases. First, it's somehow a complementary part of the system that you support the grid indirectly. So it doesn't mean that you should inject power to the grid. You can actually reduce load dependency to the grid. So this is one thing. And second is that you as a customer buy electricity when the price is low in off-peak and use it when the price is high on peak. So it means that it has some economical benefit for you. So again, it's dependent what kind of country we are talking. So if we are talking about the China, there is another benefit that you can prove that you provide the electricity for yourself. Then you can get some intensive actually from incentive from the government. So it means that you can provide electricity for yourself, or you isolate your system from the grid when the stress over the grid is high. So, hello, welcome. Yeah. So we have different types of the actually technology for the DG sources. We have some conventional technology based on the actually traditional generator. So traditional, one of them is the actually diesel generator. We had the micro turbine and also low speed turbine. So these type of technology are somehow are traditional sources, but we have also some new generation of power generators. based on electrochemical devices like a fuel cell and storage devices. We have the high power and high energy, we can see later. And we have renewable energy, photovoltaic, wind turbine, and a small hydro. Does anybody have any idea about the, for example, fuel cell? Is it good, bad, interesting, useless? So, fuel cell, yeah. So, we will see. But this is just a sample of DG sources. You can see, for example, micro turbine is one of them that can provide power less than 100 kilowatt. I mean, it doesn't mean that, you know, only this one. So, for example, here fuel cell mentioned less than 400 kilowatt, but you know the price of the fuel cell is very high. So if you find that one, then you should pay lots of money for this size of fuel cell. Diesel generator has this possibility to provide in the range of 1 kilowatt up to 10 megawatt that, you know, considered as the DG sources. We have also a small scale and medium scale wind turbine and PV. So when we are talking about the small scale, doesn't mean that, you know, we cannot have a large actually production. So we can see lots of power plant are close to, I mean, we have, you know, some standard power plant in Finland, wind power plant with the range of 750 megawatts. So it is not somehow say that, you know, you cannot, but what we are saying that there are some possibility to provide for local loads by this type of actually generation. So now we are going to talk about briefly about the fuel cell. You don't need to go through the details of that one, but I mean, fuel cell, one of the interesting types of the generation which can be used as a complementary source or backup source for the some buildings. So it can be industrial, residential, and commercial buildings. And nowadays is a quite hot topics that we provide electricity from hydrogen, green hydrogen, and just store it and then later use the fuel cell for providing the electricity. So it has a quite high efficiency and low emission, and it doesn't provide any noises for example, some office building that concentration is needed. So you cannot actually, it's not like a diesel generator that provide the noises also or pollution. And basically for the electricity, the efficiency is up to 40%. But when we combine heat, also we somehow capture the heat and use for the different application, like for actually some I mean the heat for the buildings or for some specific application, then the efficiency go more than 80-85%. So it is very efficient. But there are some still drawback from this technology, especially this, if we don't find actually good solution for that one, then we get in the problem for future. So first is the price. Does anybody have any idea about the price of fuel cell? Yeah. 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 Yeah, but just fuel cell, it is quite expensive. I mean, yeah. Then we had actually project. We had a plan to buy a fuel cell, and for the range of 30 up to 60 kilowatt, the price was 700,000 euros. I mean, yeah, we talked because they had the plan to. We had the plan to use the natural gas for that one. So yeah, yeah. For this case, I mean, the price was very high. but we needed, I mean, we could use as a just a,
Price is very high because there are no takers. Our production is less.
yeah. And there is other, I don't know about India, but you know, in Finland, everything is much more expensive in comparison here. Even we had the plan to order from USA, and there also was for 6 kilowatt, it was $90,000. So it was also very expensive. So it is not that much easy. But what the government plan is to reduce the price of the fuel cell 10 times more, up to 2030. I don't know how, but yeah, they are actually planning.
Portable power generation.
Yeah, probably. Yeah, they use the different, but still nowadays is very expensive. But you know, they have some targets, and they are going to meet the targets. So for this, it's a quite good that you know everything goes quite in the right order, and when they make something virtually or in reality, they will meet it. So hopefully we're reaching the point that that we provide with less actually price. But there is another problem that this electromechanical, actually electrochemical devices, they are not too fast. Yeah, so they have a very slow dynamic. Then if you are going to allocate green hydrogen in future system, then network is not in modern system that less synchronous generator are working and we have a lack of enough inertia in the system, then system will be more dynamic. And if something happening, fuel cell is not fast enough to compensate the or support the dynamic stability of the network. So for this, there are some projects that combining the fuel cell with the supercapacitor, and then supercap actually can support the dynamic part for the high power application, and then in the steady state high energy they use the fuel cell for that. Yeah. But anyway, the weakness is it's very expensive nowadays, and the other problem is it is not too fast. So probably later you're going to think that one you should about your research topic. One important is that how we can use the fuel cell and provide the stable source of energy for customers. So, I mean the technology. I'm not going to talk too much about this, but we have the input hydrogen. So we have a cathode and also membrane. So we split actually to electron and proton. Proton can pass, but electron follow this direction and provide the electricity. And by oxygen, the output can be water plus heat. So this is why we call, probably Professor can also explain more about the technology. We call it proton exchange membranes fuel cell. So we have actually this catalyzer here. Just we can actually pass the proton from here, and then electron find a different direction to create the electricity. So the next generation is the photovoltaic, that we can think about the 1 kilowatt up to several gigawatt. But for the local power generation, normally we have this possibility to use the somehow potential of the area we have, and then provide the electricity for ourselves. So it is very important source of energy that we can use. Why? Because it's somehow renewable source of energy. It doesn't provide any greenhouse gas emission, and then we have a good potential just 18 days of sunshine on Earth contain the same amount of the energy as is stored in all of the planet. So if you put the gas, oil, everything, you can actually provide as much as 18 days we can get energy from sun. So it is very important source of energy, and it's very somehow economical, and also it can provide electricity up to 31%, but it depended where you are installing. So if we provide actually somehow PV power plant in India, so generation is completely different from Finland. So because the temperature, radiation, and everything is completely different, so we have a better potential in India comparison with the other countries in Nordic countries. So this is very important, but just the example, if you are going to provide 150 kilowatt, then you need actually 4,000 square meter, and again this is not somehow fixed number, because it depended to many factors where you are going to actually install this PV panel and then somehow provide the electricity. So the operation is also is not complicated, so we normally use the silicon-based PV panel, and when the photon hit the surface, one electron release and provide the electricity, so it is not that much complicated technology, but it is very useful. So we have different types of the app. I mean, we can install in different ways. So for example, this is the conventional way that you can install everywhere in the roof of the commercial building or residential building, or you make a small power plant close to the load center, or also some space that you have available and you need electricity for that one. So this is a little bit more modern, but still not too much. And nowadays they find any area that you can use for the harvesting energy from sun, they can actually do this one. And President Trump also in the 5 years or 6 years ago mentioned that it is good that we make the border wall in the Mexican border and then install the PV there to get the electricity, because the sunshine is very good that region. Anyway, so you can actually use the potential to provide the electricity from PV anywhere. But we have also some more advanced technology that maximize the harvesting electricity from this technology. Just one simple example is this. So we have a box for that one, and the reason is that if some storm or something happening, it doesn't hit the PV panel. And it's changing based on the direction of the sun. So we always have the maximum actually radiation to provide the maximum also power. So if the storm or something happens, it can get back again to the box and pretty matched with the, for example, residential building. cases, they have recently one project to provide electricity for a sauna in the middle of the lake. So in the lake, they have a small island that some people go for some fun during the winter. I don't know if, ice ski or such a activity, but they make shop, restaurants, and sauna. And the owner of this building requested to provide the electricity 300 meters far from the sauna. And the reason is that they don't have too much space. They have a small space to provide the electricity, to provide this activity. Then it's 300 meters, and then they ask about wind, not PV. Does anybody can guess why only wind, not PV? Exactly. Yeah. 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 Exactly. So they need for the sauna, and most of the time such activity, they have a hole in the ice, middle of the lake. When the temperature is minus something, they go to sauna and then jump to. I think it's one time I did one time per life is enough for me, but it's a nice activity. So during that time they need electricity. They don't have PV. So wind is much more feasible for such application, and then they provide 2 kilowatt 300 meter far from there to support the sauna. So but for such a cases, if you have similar activity in India but not this ice, because I know that it's not that much easy to find the ice over the lake in this region. So, but probably similar case when we need the electricity. This type of technology, solar, can be extremely useful to provide the electricity for remote places when we don't have too much access to or easy access to distribution grid. But again, there are lots of projects all over the world that they use this potential to provide the electricity from the PV. So one of them is in South Africa. So you can see that it can provide 96 megawatt, and then support the 80,000 homes. Does anybody knows that what kind of DG system is this system or this power plant? Yeah, actually it's like a grid forming, because they don't have access to provide or be connected to the grid. And the reason is that they are 96 megawatt. They are not distributed generation. They are power plants. So for this case, we don't call such case distributed generation system. They are power plants, but they provide electricity. After I said that 5 years, you see that you just pay for the maintenance. Installation fee can be actually compensated. So it has a lots of benefit for the country. This is why I said that you will be future player in the Finland. So you should consider that. So for India, so you should consider that your country is a rich country. You have lots of natural resources that can be used, and especially from the PV. Then why not? As Finland somehow declared that we are going to be number one in hydrogen. Why India, uh, uh, when we have this potential India, why not India become the first one in the PV or one of the biggest leader? I don't know actually, Professor, what is the situation for PV in India? Is it too advanced or? Mhm. Mhm. Supporting. Okay, yeah, it's excellent idea. Yeah. Mhm. Yeah. Yes. Yes. Yeah, this is very important actually. I mean, the important thing is that we have the potential, and then we can use this potential. And even in Finland, when this war between Ukraine and Russia started, so uh, the, this uh, Ukraine had the plan to join the NATO, and Finland has the same. So they were in the same side. And then Russia stopped transferring the electricity and gas to Finland, and the price became 4 times more. And then lots of the people actually use the local actually PV. I don't know, 10,000 euros, something like this, and provide the electricity for themselves. And nowadays, when the price goes down, still they feel that this is a very good business. So lots of new job created in the Finland based on this idea. And I can promise you, if you provide such a cases, that because lots of components or technology are much more cheaper available in India, China, and some similar countries. You have lots of potential and resources. So if you provide this one and you guarantee reliability of such system, you can find easily. I mean, at the beginning, it's a very challenging to somehow guarantee the system is working well. But if they trust you, you have a plenty of customer in European side, and it's very somehow good business for your financial side. So I know that they are very interested to good job. So it could be somehow interesting topic for your future career. Anyway, so we have different technology concentrating solar power, and this type of technology are, as you can see, we use the actual mirror to reflect the solar to this part. We call it receiver, and we have sometimes like a molten salt with the temperature is 200, and it increased to 600. So this molten salt is coming from this pipe to this storage, and then go through this pipe to the water and provide the heat, steam, and the steam used for the turbine, and then the temperature goes down to 200 again and return back to this storage and go to receiver again. So by this you provide the steam, and like a steam turbine, it can generate the electricity. So now I have a question from that gentleman. What is your name, sir? Yeah, you. Asha. Asha, do you know what is the benefit of this technology? I mean, why we have this storage here? Why do we need it? Asha. To maintain the temperature. You are like a politician. Say something. I can accept it or reject it. Okay. So, okay, Asha. You. Sorry. Your name. What is your name? Nose. Roseya. Roseya. So, what is the benefit? Yeah. Excellent. Yeah. So uh, when they actually reach to the evening, then we don't have sun, then we can store here and continuously use it during the night. So for this reason, we need the storage here to store and use after sunset actually. Basically is based on superheat. I mean it goes to, I mean dependent what kind of technology we use, but it goes, for example, for molten salt it goes to 600 degree. Yeah, but in I mean when it's cooled down, then it's go to 200. So by 200 you can provide, but it's not superheat. Yeah. So this is a project in Atacama desert, and if you see that storage can provide 13 hours of the full load storage. Actually here we have two, and we have also here, and then this is a desert that we have the maximum radiation. So we have plenty of actually similar cases in USA, but this is for the Chile, if I'm not wrong. If yeah, it's in Chile. Then if you don't use this potential, you cannot use this land for, I don't know, farming or this type of thing. So it is a somehow type of the land that the government use in the most smart way to provide the electricity. And this project also done by Abengoa in Finland, in Spain, sorry. Okay. Any questions so far about PV? Yeah.
So this is the position, the angle of the reflectors keep changing, or they
I mean, basically, in the conventional system, it's not changing. But nowadays, they are trying to actually fix the angle of the mirror based on the actually the sun direction.
for that, why can't we use smart clock also?
Smart what?
Like a sunflower
Yeah, yeah.
rotating.
I mean that one is quite expensive if you are going to go, but now you just fix it and then use the change the direction. You have the sensor for that one, and then yeah, 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 yeah. They have yeah. So, but if we use some that technology, yes, yeah, it's very smart, but it's very fancy also. So it's economically will be probably not that much feasible. And then another thing is that such a desert, they are not that much subjected to a storm or this type of things that happen, for example, in some countries like Finland, because in Finland you have plenty of time that we have a storm, or so probably it makes the system a little bit unstable. But here is much more, and USA also is a country that they invest too much about this technology, and the average consumption in USA is 13 times more than the average of consumption in the world because of the industrial sectors. So for this, only rely on the oil is not a good idea. Now President Trump returned back, and then he's not that much actually believed to renewable energy, so the story is different. I mean, basically, this is very good, but it's not enough for, yeah, 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 yeah. And I know that 2006, the government of Canada started to increase such technology, but then they see that if we use maximum potential from solar, then and also phasing out the nuclear power plant, The gap between consumption and generation was 24,000 megawatts. Yes. So for this, they said that only relying in this technology is not enough. Still, they have also nuclear power plant, and but they made a very big at the first stage was the research to. Beside this one, they optimize the energy consumption with the new types of smart loads, and then maximize the PV, wind, and such cases that help them to reduce the dependency on nuclear power generation. Yeah. I mean, nowadays we have actually power plant based on nuclear, but the government switch more in wind. Yeah. Yeah, yeah. I mean, you cannot actually compare Finland with a big country like India, because India is very big country. We have lots of actually. I mean, the resources in Finland are limited, but they maximize the benefit. Yeah, yeah. Then I always say these things, yeah. But basically, providing the electricity, even you have enough resources and money and everything, but providing the electricity for 1.5 billion people is much more challenging. But I'm pretty sure that you have also brilliant actually researcher and an engineer in India that can handle it. So it's dependent to the mindset. I normally say these things. Doesn't matter from India or from European side. When I talk with the student, I said that I do recommend you travel and spend at least some part of your study in foreign country. But if you don't have any strong reason, return back to your own country, because if everybody leave the country, who build the country for future generation? Yeah, I know that probably sometimes economical situation is better, they can pay more, but this is not very it's important, but it's not actually, I mean, the country is also important. Yeah. So I always encourage you go somewhere, but return back again. The sky in the other country is not green, blue, more blue. Okay. Any questions so far? Yes.
Considering this example, where is the electricity transported to? Like
Grid.
this grid, example of this particular this
Mm-hmm.
Atacama region. So if whatever the energy is produced, where is it exactly sent?
Yeah, actually, this is the far from the local side, actually the load side. Then this is why we said that probably later we will talk about the grid forming converters. I'm not sure that you know that one or not, but you at the end of this course you will see. Then it reacts like a power plant. Then we have actually a transmission line. Actually, we send this power to the close to the consumption loads side, and then we have distribution grid and distribute between them. So it depends, but I think that it here is mentioned somewhere. It's like a 60 something kilometers. Yeah. Okay. Yeah. 60. Yeah. So for this reason, I mean, it provide, if you buy, it's if I'm not wrong, it was 700 hectare for the PV cell, no, for the mirror, and 300 for the PV actually, PV panel. This is a part because this is a combination of the this thermal base and also PV base. Yeah, so it's a complex combination of the actually two. If I'm not wrong, total area that they used was 1,000 hectare for 212 megawatt. Yeah, so if you are going to buy such a land, the price will be extremely high, and in some cases it's not possible. It's impossible. So the best is that you get somewhere that the land is not used for the live or for the farming, and it can be actually useful for providing the. Yeah, it depended, where you are and what kind of possibility you have, not just in the energy. Do you know what is the most famous part of the world for providing olive oil? Olive oil. Do you know? What is your name? You. Jay? Yeah. Do you know where is the most? Thailand. No, it's in Spain. Yeah. And do you know, probably it's happened recent year that they get the first place. And the reason is that I was in 2010, I was in they have two historical city, Cordoba and Granada. And I traveled there and I saw just the desert, just the mountain, nothing. But last year I went again the same direction and I saw the government just plants 50 million olive trees. 50 million. Yeah. And then after less than 10 years, they get the position as a first country for providing the olive oil. I'm not talking about the best, but this is one of the best and biggest. So the reason is that they had such a potential which using this way. So if you have any potential to try to maximize this potential and get the maximum benefit. So it can be in India, it can be for wind, solar, hydro, anything. But this is important that you have this mindset that in future we need this one. Anyway, any question? Yeah.
This part is out of like the desert.
Can you?
South of that.
Yes. Yeah. Yeah. Yeah.
They have a desert.
Yeah. Yeah.
So they can utilize this thing.
Yes. Yeah.
Like India and other countries, they have agriculture land.
Hmm.
So such projects are not possible in India. But PV, like regarding PVs, I want to explain like we have like in India. Now there are some certain companies which are coming in front and they're providing PVs in EMI basis. Like they are installing free of cost
Yeah.
to a big society. They are targeting a big society and then they install it. And whatever we are paying to the provider, right? Electricity provider, we have to pay them to those companies.
Okay.
And
Like a
for the
pro.
5-year duration, 3-year duration, that is decided by the company, the agreement between the company and the
Yeah.
society. So these trains are there in Mumbai, Pune, and rest of rest of India. So, like these things are happening.
Yes, it's
Even we have this solar fields across Karnataka
yeah.
and few part of Maharashtra.
Yeah, I mean, basically, this is not the only technology that we are, but we are responsible for the future. Yeah.
One more thing is hydro power, right? Hydrogen cell. So that even we have nuclear power. Those are like for India there are many threats. So obviously people are not going for that technology
Yes.
immediately.
Yes.
Like even Pakistan, your country, and the subcontinent, they are not directly jump to that because of that threat only.
Yes.
And there should be a policy for this, and it takes a long time because you can't put nuclear or hydro types of grids
Yes.
across the country. So then you need some regulations.
Yes. And Chernobyl also.
That's the most challenge for us.
Yeah. Yeah, I mean, basically, I'm saying that this is why we talk up to 2000 and after 2000. Yeah. But this type of technology, I mentioned said that if you have such a potential, you can provide. But otherwise, you are discussing a small scale power generation. So there is also such a potential to provide the electricity for yourself. So this is why the government of the China said that you can provide electricity for yourself, and we encourage, we pay you, but because of the grid code, you are not somehow eligible to provide for the electric or inject for the electricity. But basically said that if you stay in your home, nobody come to pick up you. You should actually find the solution for the problems, and this is the responsibility of the current generation to think about the new future generation. If you said that we don't have actually such a potential to provide the power plant in India, I don't believe it, because potential in India is very, very high. And if you could not actually make the solar power plant in India, so which part of the world you are going to do?
No, we have.
Okay.
We have fields.
Yes.
Solar fields.
Hmm?
Solar fields.
Yeah.
So many solar fields are there
Yeah.
in mid of the India.
Yes.
In Karnataka,
Mm.
Maharashtra,
Yeah.
Nagpur.
Yeah. Mm-hmm. Mm-hmm. Yeah, it's very big. Yeah. Yeah. Excellent. This is why I said that the potential is very, very good, but also you can think that I'm not going to advertise something, but what I can say that you have such a potential. You can create a business in India with cheaper price and sell it in the Europe with better benefit. Yeah. So, any question? For it depends actually. I really don't know which one is more efficient. Mm. Yeah. 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 Yeah, this is the technology, but I'm saying that it depended that what kind of technology are more efficient or what kind of potential. Uh, it depended where you are going to use. So, for example, this CSP you can use here. Mm. Yeah. Yeah, this is why I'm saying. Mhm. Mhm. Yeah, the most important things that we need for such a technology is that this technology is not that much efficient or useful when we have a cloudy situation. But for the PV is partially can still provide. So this is one thing that they consider. In Iceland, they try to dig the land and go. They mention each 100 meter, the temperature increase 1 degree. So when they reach close to 10 kilometer, the temperature pass. In Finland, they said that after 7,500 meter, the temperature goes 126 degree. So by this, they could use the geothermal and provide the electricity for the heat for the buildings. And in our university, they spend a huge amount of the money to dig actually land and go inside. It was a case study at Aalto University, and the target was 7,500 meters. But when they reached to 6,000 meters, it was some stone, and they said that it could not go more. So they actually shut down the project. I think that they spent probably several millions euros, but then they decided to stop it. So that potential was not existed there. And one other problem of this technology was that after, because it absorbed the heat from the soil, then after 20 years the soil will die, and then all the plant will also die. So it was not somehow sustainable technology we could use. So at the end, the government say that, you know, the best technology based on the situation of the country is that we provide the electricity from wind, and then we have actually can use the PV. And the reason for PV is that we have a short day during the winter, but we have very long sun during the summer. It's more than 20 hours. So by this, again, government think that, you know, it is better that we find a solution to store this one, because you cannot provide the electricity from the PV during the summertime, and we say we don't have anything during the winter time. So this is why they put the roadmap, this green hydrogen technology in the roadmap to provide the hydrogen, store it, and then use during the winter time. Yeah. Yes.
Sir, in this technology,
Mhm.
how much reflectors are being used and the temperature is being, energy is being
Mhm.
captured.
Yeah.
Sir, can we do a what is called controlling of these things? Because at some duration we don't need that much of energy.
Basically, without control is not possible. So definitely, this is important. But what I can say, for such technology, the most important is we have actually very strong radiation. So for this reason, this is probably can be used some part in, I don't know, Atacama Desert or in Nevada or something in USA. But this PV panel can be used everywhere. Even in Faroe Island, 7% of the electricity. Faroe Island is an island in the middle of nowhere. But still they have this potential to provide the 7% of the consumption from PV. Yeah. But such a case doesn't work. This type of technology is not feasible in some even central part of the Europe.
If this is the thing, we can directly put on window package.
Yeah.
So that we can consume the entire, that building can be consumed, energy can be used from this.
For the building, I don't see that much actually. Probably you can use for the some specific application, but if you are going to use for the electricity by steam and this type of actually production is not. It's like yesterday I said that you can go to supermarket by truck or by like a passenger. This is possible, go to supermarket by truck, but it is not actually efficient way. Assuming that 7 people go by truck in the supermarket, then traffic. Yeah. So.
Government is encouraging high-rise buildings.
Yeah.
Some towers, 30 and 30 floors.
Yeah.
So we have to mandatorily install those PV modules.
Definitely. Yeah. Yeah. This is even in some third world country that still they try to do this because of several reasons. It's feasible also, but it depends on where we are talking. So in the building it's like apartment building. Even we have actually some electricity to support the corridor line. This is also is very useful. And you can put the PV panel in the roof and then use it. But I mean, this CSC should have a very somehow continuous actually radiation to provide the electricity. Biomass, yeah. Yes. Yeah, I'm not sure this is correct or not, but I heard also that because in some region there are lots of elephant and this type of biomass can be also provided by I don't know if it's correct or not, but I heard something from somebody. Yeah, yeah. I'm not sure. I mean, because nowadays, I mean, we must actually use the different technology to take care of our environment and also our resources. So I heard this, but I'm not sure that this is correct. Yeah. Okay. Yeah. Nice. So, this one, it depended to radiation. So the efficiency can change between 5% to 40%, but it depended, Yeah. Yeah, this. Yeah. I mean, basically, we need water also. But it is not that much. I mean, it's more for the maintenance stage. And nowadays also they use because assuming that this is 700 hectares, and a fault happening in one of these, So how would you like to actually notice? Nowadays they are using the drone to monitor drone for the monitoring the system. Yeah. So by this they are going to somehow reduce the risk from the fault or this type of, or at least they can detect it faster. But all in all, we need a lot. It's not just we implement this technology and just get the electricity. No, we should consider also this production. Yeah.
So what type of control they are using in this person?
Control. Come on. So I said that you are a controller. That's enough for you. Yeah. I mean, no, basically, let me give you the right answer. For the other common projects, because I was working in this project 6 months, so I have just a general information. They use this SPC technology, and the company, they call it GEMA, but here in Spanish they call J, they pronounce K, and the Finnish also say Ye. So GEMA company or GEMA company provide the converter, and the converter was 1,000 megawatt. So it was a combination of the 3 parallel converters. So each converter had the capacity 350 kilowatts. So when the radiation changed, I think that when probably reached the 35, so the radiation in 9 a.m. is different from 10 a.m., 11 a.m. and 1 p.m. So when we reached the 35% of the capacity, the second converter connect parallel with the first one, and then when it passed the 65, third one also connected. So the technology they used was this parallel connection for this project, and then they used the SPC, synchron power controller, And if you're going to know more, I can explain the details probably in chapter 5. But the reason was that in SPC, the model that they used was based on the admittance of the system. So if instead of actually providing the somehow derivative, you have L R, okay, L di to dt. So when the converter passes the current, inject the current, it takes the derivative of the current and it increases the somehow disturbance. So then they decided to change the voltage control to current control. Instead of impedance, they use the admittance of the system, and this 1 over L di to dt plus R work like a filter. Instead of increasing the disturbance, it filters the disturbance. It's a very smart actually technology they use it. But we will discuss about the details of this technology later. So it's enough, or we can, I'm okay, we can continue, but it's fine. Okay. Let's have some break and then later continue. Okay, thank you. So, welcome back. And the next technology that we are going to discuss briefly about it is the wind power. So wind is also very interesting because we can provide a huge amount of the electricity from wind. But we have also this possibility to provide from wide range of the actually production, from couple of kilowatt up to some gigawatt also. So it's a very interesting because we can make the plant for longer duration, and the installation cost is quite expensive, but you can get the lots of power and it can be compensated fast. And it has some limitation. For example, if you are going to provide the electricity, the speed of the wind should be at least more than 3 meters per second. And also somehow this is very useful technology when you are going to provide electricity for remote places that transmission or distribution line are not that much easy access. So also the problem for the hydro and this type of technology are not needed for this production system, and also it is based on renewable energy. It doesn't provide any greenhouse gas emissions. So basically, very nice technology for providing electricity for our system. So this is just a sample of some a smaller scale generation from wind. So it can be even 400 watt up to 5 kilowatt also for the residential building can be used. So it is not that much complicated, but the problem probably is regarding the diameter of the system. So if you are going to, for example, provide such a case, or this one for a residential building, the diameter is 6.4 meters. So it is not that much easy. Said that in the, I don't know, my residential building or in the terrace of my apartment, I'm going to install this one and provide electricity for myself. But all in all, the feasibility for providing electricity from wind is highly efficient and also high demand. So just briefly, I'm not going to discuss with details. Later we get back about this technology, but basically permanent magnet synchronous generator are used for providing the actually electricity from wind. So because the speed of the wind is not constant, so what we are providing is like this. So you cannot actually use this one for the load because we need to have the high quality power with the constant frequency and voltage. So for this case, we need a rectifier here to change the this AC power from AC to DC, and then we need the regulator to here. So for example, after this part, you see that we have a little bit fluctuation here, but we use a voltage regulator here. We regulate the voltage to 800 volts, and then by use of a DC AC converter, we convert the DC to AC with 50 hertz frequency and also match with the voltage of the grid. It can be 400 or 20 kilovolt based on the standard of the country. So we normally use, even we consider this is like a, I don't know, 5 kilowatt. Still we cannot use it for the transmission line. Does anybody knows why? So we always said that this is the close to the load center. So load is normally connected to the distribution grid. So why we don't say that this is not for the transmission line? Voltage and frequency, but transmission and distribution have the same frequency, but the voltage level is different. But even distribution also voltage level can be different. But the main reason, does anybody has any better idea? Sorry? Based on what question? Now I'm saying that this type of generation, for example 5 kilowatt up to 10 megawatt, they are distributed generation and we can provide such electricity, but we can use this electricity for load centers or supporting the distribution grid, but we cannot support transmission or inject transmission grid. Does anybody have any idea why we cannot? No? High harmonics, inertia. Inertia is good. Harmonic is bad. So more explanation, idea. Arya, do you have any idea? Is your problem? I can't pronounce your name easily, so this is why I said, yeah. Okay. So I ask your name, but I can use a different way. Arya, do you know him? Yeah. What is his name? Siddhan. Okay, Siddhan? Yeah. So do you have any idea about why we cannot use this one for transmission line?
Basically, in distribution system, the other devices are get connected to that,
Mm-hmm.
so that the power supply get fixed, so the devices does not cause any harm. So that's the distribution system.
Mm-hmm. Let's see another one. Okay. power loss is, yeah, okay. No, I mean, basically, the main idea for the local power generation or this type of distributed energy sources is one aspect is losses. But the question is that why we are not allowed or we cannot actually inject from this converter to transmission line. So for example, if we have a source like a 5 megawatt, but we have only transmission line, then they say that no, absolutely no, I don't care actually you provide the 5 megawatt, but you cannot be connected to transmission line. Okay, the answer is that this type of technology, converter-based technology, we call it custom power technology, they are designed for distribution level, okay? So these are not actually components for the transmission. For the transmission, we have different technology. We got flexible AC transmission system, so FACTS devices. So the components for transmission are different from the distribution. So you cannot say that, you know, I'm going to provide electricity and then by connected to this distribution transmission line. Okay, but then the question is that, so why we provide electricity from wind or solar and then transfer it by transmission? Because we cannot, for example, in OACOPC project, we had 65 kilometers far from the load center, so it could be by transmission line. So then Edris told it is not possible, but we need a converter to provide that one. So it's a little bit contradiction. Am I right? Yes, Arya? Yes. Okay. No. Yeah. I had a student like you and said that sometimes said yes. He said yes. I said but sometimes no, and then sometimes yes, sometimes no. Okay. So you're like this. Anyway, okay. So this is true. I mean, this type of generation, we need always converters. And the reason is that we should, nature of the generation are different. So for example, fuel cell provide the DC, PV provide the DC, wind provide the AC. Then based on where we are going to use, we should change or match the nature of the generation with the consumption. So the nature of this generation, wind is AC. And the nature of the grid is AC, okay? So we should match the voltage and frequency of generation match with the frequency of the actual distribution, okay? But for the transmission, we provide electricity. So assuming that we provide the electricity here, then we provide actually DC line here, and then converter here. Then we have actually between transmission and distribution, we have actually power station. So it changed the actual system. In fact, we use the power station to integrate power plant to transmission line. So by power station, we use the transformer. We increase the voltage level to several hundred kilovolt, and then by transmission line, we send the power from the generation to the consumption side. So you can provide the electricity, use the converter, regulate the voltage and frequency, but you cannot connect it directly to transmission line. And this is so, if someone asks you what kind of the voltage do you have here, you should say that I don't know, but it's a distribution line. So it can be, for example, 20 kilovolt. If I'm not wrong, in India, it's 20 kilovolt, yeah? Is 11, yeah. So I mean, different country, yeah, have the different. Yeah, okay. Yeah, in some also country, 11 and Yeah,
40 kilovolt transmission there.
40,
400 kilovolt.
400. Yeah, 230 and 400 normally for the different countries for the transmission. 11 and 20 for the for the distribution. Anyway, so we have also micro turbine, and this is very popular source of DG. So you can provide the electricity for local loaded. So it also provide up to, I don't know, 300, 250 kilowatt. And the main part actually, for example, in USA, in Texas, and this type of actually the storm happening, then the American distribution or transmission line are not that much strong. So basically, this type of technology is extremely popular in USA because it can be used like a small generator for them, and they can actually have access to electricity when this type of a storm happening. And next is the battery. So we know that we are talking everywhere about the storage devices, battery, and we have two different categories for the battery storage. So we have high power technology and high energy technology. Does anybody know what is the difference between high power and high energy?
Batteries have high energy density,
Mm-hmm.
and supercapacitors capacitors have high power density.
Mm-hmm.
Supercapacitors can instantly charge and discharge
Mm-hmm.
within time. Batteries will store discharge slowly. So they have energy density, and supercapacitors they have high power density. And with the combination of both, we will have high efficiency.
Okay, good. Excellent. Thank you very much. So we have two different types. We can say that high power and high energy. High power like supercapacitor. As mentioned, it can be charged and they charge fast. But high energy is like a lithium-ion battery. You can charge it and recharge, but it's not fast enough. I mean, lithium-ion is medium level, so but in some technology like fuel cell is even slower than the lithium-ion. So for this case, when we are actually talking about the technology, then we said that we have battery. So when we are talking about the system, so assuming that you have a grid here like a three-phase system, so it has the impedance of the grid, and this is the load we have here. So then you have actually a converter here that provides the electricity, AC, DC. So we have actually DC bus here, and there are three-phase also. So it can be like this. The frequency of the system is 50 hertz. Then we're reaching some peak time, and L2 is also for the load increase, and the frequency fluctuating a little bit more, which we don't like it, and it's coming because of the stress over the grid. And then we use actually this storage to provide the support to the load. So then if we have, for example, 10, which increase to 20, and this 10 is injected, but you see that 8 is add, so we have 18, and then we have 2 from here. So 2 plus 18 is 20 KCl, okay? But what is happening is that, you know, when we have a slope, it's fast. Okay, when this fast changing happening and we have like a lithium ion battery, then it cannot supply the load changes so fast, because we need to pass this transient and reach to the steady state. So for this case, we have a transient stability problems, which is not good for the sensitive loads. Because these sensitive loads, like a computer or some other technology, which probably computer is not just playing with the game or like this one, so you can use for the programming or also monitoring lots of other things. So they can tolerate the disturbance for half a cycle. So it takes, in the best situation, takes one cycle is 20 milliseconds. So for 10 milliseconds, it can tolerate this turbulence. So if we consider the frequency 50 hertz, so TS 50, and F is 1 over, sorry, F is, T is 150, so it's 20 milliseconds. So for 10, half a cycle is 10 milliseconds. And 5 milliseconds goes to the detection of the, so we have actually 5 seconds to react, 5 milliseconds to react and compensate the transition. And this lithium ion is not fast enough to compensate that part. So for this case, they use the actually hybrid energy storage combination of high power and high energy technologies. So it's like this one. We use the lithium ion, and then we use the supercapacitor. So we have a DC-DC converter, and we have a DC-DC converter. So we provide the DC bus here, and based on that, we have a DC AC and provide the grid voltage here. So when the turbulence happening, we go from this direction, and we are a steady state, we go by this part. So we call this long duration support, we call it high energy. This type of actually technology which can support the power for load or for the grid for longer duration, we call it high energy. And some type of technology which can provide support for the high power or changes, they are fast, but the capacity is not too much, is high power technology. So just the example, supercapacitor, high power, lithium ion. Yes? Yes. Yeah, we have also here, somewhere I mentioned it. I mean, none of these technology are not mature enough, actually. Yeah. Yeah, so, but we are developing. So, for example, nowadays we use the lithium ion for the electric vehicles. But do you feel that they are mature enough? So, can you compare the Tesla is better or Mercedes-Benz EV? Which one is better? Why? So, but now the competition is that Mercedes can go up to 1,000 kilometers when full charge, but when you use the Tesla, it goes to 500. But there are other things also. What is the weight of the battery? What is the size? What is the price? And this. So what they are doing nowadays is that they are going to optimize first the structure of the system, and second is that then by this they can, when the losses reduce, in fact you can optimize the size, weight, and cost. So just a simple example. Let me get back to this whiteboard. Supercar. Yes. But I mean, when we have actually this protection, yeah, definitely, yeah. It's very important actually. So when we are talking is like an ideal operating condition, but definitely we should consider. So, just a simple example. Assuming that you have a lithium ion here, yeah? Li-ion. Yeah, then we have also supercup here. So we said that we need a DC-DC, and we have also a DC-DC, and then we have a DC bus. Okay? So it doesn't matter what happened there. So, Udaya, tell me, do you like this structure or not? Assuming that you are going to, because this structure is used for the heavy duty vehicle, combination of lithium ion and supercup. Do you like it? Yes. How much you like it? Too much? Okay. Okay. So, now I pay you 1,000 euro to provide something better than this, to increase the capacity of the system, and also somehow compete with another company that use this technology. Do you have any idea? Different structure? Yes.
That is one thing that I can propose.
But the other technology, more than
Yeah.
there could be more than
Is off.
Yeah, more than that, I can't say as of now, but this is also not at coming to the phase with the industry to adopt this one. It is still
But this is the adapted technology in heavy duty vehicle.
heavy duty.
Yes.
But we are not aware for the two-wheelers or of some three-wheelers. Yeah, this is one okay. Means like I can say that it can enhance the battery and protect the battery against the falls.
Okay. So it means that I, as the owner of the company, cannot pay you 1,000 euro because you just approved that this technology is good.
Technology is good.
It's good.
Yes.
You like it?
Yes.
Okay. Is there anyone to say something different than I give 1,000 euros as a, yeah, honestly I give. Okay. I had an Indian friend and I didn't have the currency and he gave this in, remind me like a grandmother actually. So I give this one in my pocket. I bring it from the Finland. So, Arya, motivate you? No. He's not looking for the money. He's looking actually for the different things. So, you. Any idea?
So you are talking about source only, or the load can be DC?
No. I can say that, this is the technology we are using in my company. I use for the electric vehicle. Okay?
Other than
Why? Because I'm going to drive, but this heavy duty vehicle at the beginning, it should actually get some acceleration. We need actually something high current, so it can be supported by this, or when I'm driving, then I'm going to pass somewhere. But then later, for the longer duration, I use lithium ion. And by this full charge, I can drive 10 hours. But my concern is that in 10 years later, my competitor company developed the technology with 12 hours, but the same price and the same size and everything. So this is my concern. Do you have any idea that, probably with the same structure, I developed something that compete with this company and still have the first place?
So you need both in after 10 years.
Yeah.
Iron is super capacitor. I can change
Capacity,
capacity.
but the problem is that if you increase the capacity, then the size increase, and then
So capacitor charge.
one more thing, without increasing, that I can.
Size,
Yeah.
as I know, is 10 times less.
yes, but the problem is that you cannot use for longer. Yeah, this is the problem, and the price is also high. So this is the problem. So
Yeah,
Udaya?
one more thing that we can augment one more distributed generation like PV panel we can make use that it also
definitely PV panel is also very
and
very hot topic nowadays. Basically, they say that we integrate PV. Today is the 4th of February, so it's a deadline. European project we have.
okay.
And it's we use the PV in the roof of the electric vehicle to somehow support. And the benefit is that one passenger vehicle charge 66 times, but with this PV integrated system, you can reduce per year also. You can reduce the charging to 38 times, they said. Probably is a little, but you can reduce but you cannot fully charge your system, just rely on this technology. So it can optimize. But anyway, that one is different story. I'm now talking about this story because we are engineers. Battery management system is getting back to the control, and control can be, because we have 3 different types of actually optimization. One is based on the control, second is based on the structure design, and third is the material. So for example, you can use the silicon or silicon carbide. Which one is better? Silicon carbide. Okay, so now again get back to this one. I have 1,000 euro I'm going to give to someone. So, except the professor. So I'm assuming that he give the right answer, and then I should really pay. So, any idea?
Sir, to increase the efficiency of battery life, we can use the regeneration mode, like on any slope with the.
Did I ask about the life of the battery? Did I ask this? I asked about this duration, not the life cycle.
No, I was talking about duration.
Okay, tell me the duration. So you said that after 1 year, when it's some problems happen, and then we can use that one, still keep the same life cycle or duration.
No, actually, it is not for after that few years the battery duration gets it actually decreases.
Mhm.
I am talking about in a consistent mode if the vehicle is running, so
Mhm.
that if we decelerate the accelerator on that basis used by the regeneration mode.
Mm-hmm.
Actually, repetitive braking.
So then it's better.
Yes, it will be better.
So it will be more duration for the driving and also, okay, for sure? Okay, let's see. I can give 100 euros for you if it's correct. Yeah, okay. So any other idea? No? So I'm not going to say that, we should know this one. I'm going to say that we are engineers. Always we need to upgrade our system, and system should be, yeah.
Energy density of lithium ion should be increased.
Yes, this is something that we should consider, and yeah, and the technology is
Solid state batteries.
yeah, yeah. But when we assume that we have exactly two technologies, then three important things is the structure, control, and the material. So if we get back to these things and said that my system is mature enough, but I'm going to develop it. It means that I get a good feedback from the customer, but my concern is that my competitor can provide something better. So what I do is this one. I said that in a state of actually, because when we charge this package, we charge the lithium ion, and then we convert the DC voltage, so we have one conversion here. Then, assuming DC-DC converter have 95%, 93, sometimes 98, something like this, but we have, for example, 5% losses here. And then again, we come here, 5% more, we charge the supercapacitor. And then when we use it, again, we use this supercapacitor again, another conversion, so 5% again here. So totally we have 15% losses from here, okay, 3-stage. So I'm engineer, I'm smart, I'm the brilliant, I got my PhD or bachelor or master in NIT, so I said that in a state of go 3, I'll go directly from here to here. DC, DC, okay? So what happened? We charge this one 5%, and then they charge this one 5% also. So instead of 15%, now we have 10%. Okay? This is the structure design. And the other things is that control. So what we use in battery management system is the old version, but we are not going to use the same technology for the future. So for example, when you use the PWM for the control, you have a structure, switch it, and it provides based on that signal for the converter, and then. But nowadays they said that we use the predictive control. So predictive control said that I choose the switching based on the optimal operating condition to minimize the switching losses. Later we see this one. So then control of the converter also can increase the efficiency. So nowadays if you use the PI controller, is the efficiency equal when with the AI-based technology or machine learning based or predictive based? If they are the same, why do we need to change our controller? So one efficient way is to change the controller. So if we use a different controller, then we can reduce loss from 5% to 4% or 3%. Okay? So assuming we had 85% for 3 converter, but now we have 2 conversion, and in a state of 5%, we have 4%. So we have 8% now. Okay? This is another benefit. Then I use the silicon carbide, silicon technology. Assuming that, the silicon, if we change to silicon carbide, what is happening? This material have the less resistance and also is somehow more lighter. So why I don't use the silicon carbide transistor instead of silicon? What is the problem of the silicon carbide? Price. Yeah, it's more expensive, but for longer duration, it makes sense. So for this case, we can also optimize. Just give you one example. Some Power is a power electronic company. They mentioned that the losses, they use the silicon carbide instead of silicon for the DC-DC converter, and they said that the losses is 75% less than the converter which use this silicon. So assuming that we give 50% less, so it means that by using this silicon carbide, we can reduce the actual losses to 4%. Okay, so we reduce from 15% to 4%. So it means that if one full charge battery could reach 800 kilometers, now by this technology, we can go to 960. Okay, but let's say another things. I said that I provide 800 kilometer duration with the same structure actually, but it means that if the pack is that size for the first 85% actually efficiency, for this technology the pack will be smaller. Why? Because we optimize the losses. So by this, when losses optimize, size optimize, weight optimize, and if you paid, for example, 2 kilos for something, now you pay 1.5 kilo. So it means that the price is also optimized. So you can deliver your product in two ways. First, that the price of my final product is less than your product. This is, or with the same price, the duration of my battery is more than. It's like a competition between Tesla and Mercedes-Benz. Mercedes-Benz said that, you know, my vehicle goes to the 1,000 kilometer with full actually charge, but Tesla said that 600. So I said, okay, if the price is okay, I prefer to go for Mercedes. No, which one you go? No, I go for Tesla. Okay, it's more beautiful. No, I go for Mercedes-Benz because, you know, it's more efficient, so why not? So this is our mission. You are engineer, you should think about engineer. No, if you ask my father, he's not engineer. I mean, he's engineer, but he's not electrical engineer. So if you ask him, he said that, okay, there are two batteries, but then the duration is this one better, so I go this one. But he doesn't know that, you know, if it is optimized or they cheat with you. Because they can increase the size of the battery, weight of the battery, and then capacity increase, and then it goes more. But I see that, you know, how much I paid for this battery. If I paid the same in these two cars, so makes sense that, okay, go for that one. But if they said that no, you know, we reduce the quality of the car, but increase the capacity of the battery, so it doesn't make sense for me. Because I'm engineer. I should think like engineer. Okay? Good. Any other question or concern or yeah? You have a PhD in hybrid energy storage, so don't ask this. I know that what you are going to ask. So this is the simple example. Don't make my life hard. His PhD topic is hybrid energy storage. Okay. Any other question? No. So this is why I'm saying that, you know, it is important that you learn the basic and then you do something feasible that or applicable in the real system, and after that you develop the model. So you cannot jump from the basic to advanced level. Go one by one. And this course at the end is completely different from the beginning, what we are discussing. And we learn together. Okay? So let's see. Any questions so far? No. Yes.
What are the different reasons for fast and slow oscillation in the system?
Different reason. I mean, the grid, it depended what kind of grid you have. Okay, so if we get back to the power system go to the more renewable. So this conventional synchronous generator in the power plant, they are connecting in parallel together. Okay, so in parallel connection of the system, the impedance is connected parallel. So if assuming that you have 10 generator connection together in parallel, okay? So Z is Z over to 10. So when you increase the generation from renewable energy, in fact, one by one they decrease, okay? So assuming 10 goes to 9. So Z from over 10 goes to Z over 9, Z over 8, Z over, as much as the renewable energy increase, this conventional decrease and the impedance also increase. So when the impedance increase, it in fact the voltage changes will be more affected by the load changes. Okay, so assuming that, you know, you have a grid. So you have this grid, okay, grid. And this is the impedance of the grid, Z. And this is load. And this is the point of common coupling, actually, a connection between load and generation, okay? So assuming this is 10, and the current is also 5, okay? So the voltage drop is 50 here, okay? And then if it is, I don't know, 400, the voltage is 350 here. Is it true? So now we have a similar grid, which Z is 1, and then this is 350, 90, and this is load. Okay? Which one is better? Which grid is better? 390, yeah? Why? Because the standard level is 400. And the voltage drop is here is 10 volt. So we don't have too much losses. So any changes in this system, so if I have another load, it changes the voltage too much. So the voltage is unstable because it's fluctuating based on the change of the load. But here is not that much actually. So the grid is stronger. The voltage is not that much affected, so we have a quite a stable volt. Did you get it? So if this type of things, this type of network we have, then this type of actually fast system is not needed because the system, I mean the grid damp the fluctuation. But in future grid, we know that we have more power electronic based generator and less synchronous generator. So we can actually predict that future grid is not as strong as we have now, this synchronous generator. So then it will be more dynamic. This dynamic is coming because of this. And then the other problem is that this type of synchronous generator, they are very stable. They provide the very stable voltage. But converter, they have just a switching mode, which is not, you cannot predict the behavior of the converter. Is that the dynamic reaction is not predictable. So for this, they also provide some disturbance for the grid. So future grid, which are dominated by huge number of the converter-based generator, they are very actually sensitive to the dynamic changes. So this is why we need a technology to support the grid and reduce the dynamic reaction in the system. Yeah. Any other question? No. Good. So now we pass the history of the distributed generation technologies, and now if someone asks you about the electricity history, what happened, you know that what happened from 1880 up to 2000 and after 2000. And now we know what is the distributed generation technology, resources, and then we know what kind of benefit it can bring for us, and probably it also provides some challenges. We said that it makes our grid with less inertia, and when we have less inertia, Abe is here? Yeah, okay. Always remember, when you talk about the inertia, I touch him, and he was very high inertia, didn't change, but I have less inertia, I fall down. So this is the example of the inertia. Anyway, so now we are going to talk about the application of distributed generation technology in power system. So we had introduction, then now is the application. So at the end of this actually chapter, you will be able to discuss about the distributed generation technologies. So does anybody can say what is the distributed generation technologies, not source? So if not, you will be able to explain at the end of this course, this chapter, and what is the actually application of this technology in power system, and what kind of technology are used for the integration of DG sources to the grid, or different part of the grid. So because it also used for the microgrid, but microgrid can be isolated from the main grid. So again, get back to this technology define. What is the distributed generation technology? Distributed generation technology is a technology for providing electricity from a smaller scale energy close to the load center. So it can increase the reliability and security of the grid. So I feel that, Arya is feeling a little bit sleepy. Yeah, no? Okay, if you're not feeling sleepy, say that what is the meaning of the reliability and security, and how it can increase the reliability and security of the system.
They are talking about the reliability, so like they are saying that can we trust whatever the grid is for the whatever the power supply should be going to the grid.
Okay.
Considering the security part is whatever the components we are going to use in the they are not damaged by the third party.
Exactly. Excellent. Yeah, I like this thing. Yeah. So it increases reliability. So it means that if you have unreliable system network, and you are going to work in hospital or some other places, instead of providing electricity from unreliable network, you can provide electricity for yourself from the reliable source. So it increases the reliability and security of the grid. Also is that it mentioned that increase the security of the grid, but it is also secure type of the sources, because when we have high demand, we can shift the load from the grid to the load. So provide actually somehow increase the security of the grid by reducing the possible actually damage or outage. But again, it can be also secure source of energy because we don't have transmission and distribution line. In fact, such an event that a tree fall down over the transmission or distribution line and outage happening in the middle of the surgery. So it affect this type of technology. Can be configured to match the customer demand. It means that if you increase or reduce the conversion, then it can be also matched with the demand. So if you increase the power, then you can also inject more power. If power is like a reactive power or harmonic loads, then you are not allowed to active power, reactive power, and harmonic. But if you connect your load to the grid, then distribution company actually send the fine, and you should pay the penalty because you request reactive power. But with this technology, you can use this model. This is the grid, this is your load, and this is a converter can be connected to your load. So reactive power can be compensated by this DG source, and active power can be compensated by grid. So you can easily handle this problem. So we can use the different types of the energy sources: battery, fuel cell, super cap, or lithium ion, and wind, solar, anything that can provide electricity. We can use this technology, so it can reduce the necessity to build the new transmission line, because we can use the conventional transmission line and we can compensate the rest from the local power generation, and it reduces the carbon emission because we are using the renewable energy sources. It reduces the peak load because we can also provide the extra load from the DG, and then somehow reduce stress over the grid. It can improve the system efficiency because it's close to the load center, and you have less losses. So this is just some example of this technology. So for example, for the hospital, we can use actually this standby or peak shaving devices. So what is the difference between a standby or peak shaving? So peak shaving it means that we reduce the dependency to the grid during the peak time and use this local generation. But the standby is for the time that grid is not reliable or we have outage, we can use it. So some sensitive loads that we need the high power quality, it can be used by this technology to provide the high quality power, because if you make a little bit actually disturbance, make a little bit I don't know, if you have a radar and then you have some interrupt and then it changed the actually signal we are sending to pilot, then it makes a big problem. So it can combine heat and power, so the efficiency goes beside the electricity. We can also provide the thermal, and also for the office building also it can be used as a standalone and peak shaving. And the main is the grid support. So what is the meaning of the grid support? We said that when we integrate renewable energy sources to the grid, it makes a lots of problem because we use the power electronic. But here mentioned grid support. It can provide supportive functionality for the grid. But what is the meaning of this supportive functionality? Any PhD student here? I'm not. Okay. Udaya? Mm-hmm. Yes. Yes. Yeah. Yeah. One is that we buy from the grid and then sell from the grid to the grid during the peak. But some other is that, using this DG technology for regulation of the voltage and frequency. So when the system is unbalanced, then voltage is changing, frequency is changing, then we can provide the actual regulation for that one. We increase the required power, so sometimes we have the reactive power, reactive loads, then it somehow change the voltage stability of the system, but we can increase the injection of the reactive power from DG sources to the grid, and then we regulate the voltage. And in some cases, when we have the more active power, so it's like this one. I'm a main grid. I have a backpack, so I put some loads with me, and you increase more, and then I feel that I'm falling down. But Udaya is a DG. So he takes some part of actually this load, and then we go together. So it means that, then my frequency is balanced because DG take care of the some active power. And in some cases, when you have the nonlinear load, in fact, you provide the harmonic components, which has lots of problem for the grid. But by providing the harmonic current components, so you can tune your controller in a way that just provide the harmonic of the load, and then the rest of the power can be compensated by grid. So by this, you can actually reduce these disturbances and increase the quality of the system. So, but what is the structure? We talked too much about the DG, and we said that we integrate renewable energy, so it means that we have a renewable energy and ask him to inject the power to the grid. Is it that much easy, Arya? No? Why is not easy? Voltage level? Yeah, switching, yeah. It can be also, yeah. But switching is it's not that much complicated. If switching is the problem, I think that you change your career. Yeah. So, you're a PhD student, yeah? So switching shouldn't be any problem for you. And I'm pretty sure that it is not problem for you. Okay, so switching is not. Then, what? Synchronization. Yeah, it is good comment. Synchronization is the one thing, but you're an engineer, you're a smart, intelligent person, so I'm pretty sure that with the advanced control design, you can somehow synchronize your system with the power grid as smooth as possible. So, yeah. So, any other comments? Yeah. You have a guard and you're going to say something. Yeah. What? Stability. Stability is important, but when you talk about the stability, it can be stability of the converter between the generation to the grid, or stability of the grid. So if you have unstable conversion system, it impacts the grid negatively, and if you have unstable grid, it impacts the operation of the grids. But I'm pretty sure that you can find the solution for that. So any other comments? So the problem is that I cannot memorize your names. Okay. So sir, what is your name? Yes. Abdul. Oh, I can promise that I can actually memorize. Abdul, do you have any comments?
Sir, I think whatever renewables are connected in this architecture, renewables from renewable energy sources, the power generated by those sources should be at maximum level with respect to its rating or specification.
Yes. Yeah, this is also maximum power point tracking is also very important. But the question is that, is it really easy to provide electricity from renewable, or is not? Arya, you always are negative actually. By this attitude, you should go to, you can be like a prosecutor or judge or lawyer, something like this. Yeah, but not electrical. You should be. Is it really hard to provide electricity from renewable energy or not? It's easy. Provide the electricity from renewable energy. Easy. Yeah, variable is the main challenging part. Yes. What? Unpredictable. One sense.
Consistency.
Harmonics is major challenge. This is correct also.
Dependency.
Dependency.
Dependency on environmental conditions.
Yeah, this is also one thing. So, yeah, storage.
Major stages in conversion from AC to DC, DC to AC. Many power converters, conversions are required.
Yes, this is also okay. So it means that you are engineer, what you are commenting. Okay. So providing the electricity from renewable energy is not hard, but we cannot provide it by chance and say, okay, this is the turbine, we provide electricity, and that's all. Okay. We should be careful to provide actually what we need, not what we have. What we have available. So the prediction is one aspect that we should consider, that how much power can be provided from renewable energy sources. And the other thing is that we have a constraint from the grid and from interfacing system. So in this course, I promise you, if you listen, not like sleeping mode and sometimes actually different, like ¿puedes hablar español? Besame mucho, this gentleman can actually. And different, you are here, but your mind is somewhere else. So, but if you listen well, I promise you, at least you can provide some signal from the converter, okay? But I'm saying that, we learn together, so I cannot jump from the basic to advanced. So we go one by one. So, when we have actually this type of technique, so the network is combination of three main parts. First is the grid, second is load, and third is the DG system. So, it should be balanced between these three parts. Anything happen in any of these sections, then the system will be unbalanced and the problem will be appear. Okay? So for this case, the main challenge is coming from the load side. Why? Because provider is the power grid. But load side are the normal people that just turn on something, turn it off, and don't care what is happening in the grid. So when we're talking about the power quality, we need high power quality. In fact, we need high voltage quality. Why? Because P or S is equal to V times to I. Voltage times to current. Voltage is with the provider, but current is the load side. So now this light is on, and in 10 seconds you can turn it off, so it means that you can reduce the load and turn on something else, then the current is always changing. But the responsibility for the provider is first to provide the required power with high voltage quality. So if someone asks you what is the power quality is voltage quality. Why? Because the customer, we have no control the customer. We should provide what they need. But the thing is important is the stable voltage and required current. Current can change, voltage cannot change. So high quality stable voltage means high power quality system. Anyway, so once a mismatch happens between the generation and consumption, then the converter should provide it. combination of the actually generation side, interfacing system. It can be multi-level converter, two-level converter, modular converter, any types of the converter. Something that converts DC to AC, okay, because we need the AC. So, converter, and then we have a filter and inject the high quality power to the system. But we need the power management and control system. Why? Because here is the DC system and here is the AC. And the AC can be 60 hertz or 50 hertz, 110 volt or 220 volt or I don't know 400 volt, 11 kilovolt, what. So you should provide control on this. So converter is like a computer. So you can turn it on, but as long as you don't know how to program, it doesn't provide anything. But as much as your program skill is more actually expert, you have a high skill, it means that you can actually program in more professional way, get more benefit, or what you are looking for can be handled by this. So as much as the controller is working better, it provides more services to the grid. So if, for example, the load is nonlinear, you can ask the converter just provide the active power, but in a smart way you can provide the non-linear part, because the non-linear cannot provided by the grid and it can be considered as a disturbance for the grid. So for this case, it is important that we know how to program the converter and somehow compensate or problem, provide a solution for the problem existed in the grid. So any comment, question, something like this? No? Yeah. Okay, good. So if now we are going to explain what is happening, we said that, if we are going to integrate renewable energy sources to the grid, we need the converter, we need to control the converter and provide required power to load side or to the grid. So, when we are talking about the converter, converter is some tools, okay? It's like a vehicle. You have a Mercedes-Benz and in your parking, but the problem is that you don't know how to drive. This is the problem. Is you have a converter and you don't know control it. It means that you have a Mercedes-Benz at home, but you don't know how to drive. So, for this case, the core point of integration is control of the converter. You can easily buy the converter from market, but you cannot control it. So it doesn't provide anything. So in this case, we see that, this is the most important part for the integration of renewable energy. So we need the source, we need the power electronic converter, and we can also need the controller for the provision of electricity for the grid or for the load side. So this is the general structure. That one is this part is the system we have, but what is happening in reality? So we have a DC bus here. We have a multi-level converter, but doesn't matter, multi-level, two-level, it depends what is the voltage level and what is the power level. So we have actually this interfacing system. We have actually impedance here. It can be combination of the filter, transformer, impedance of then we have the equivalent RL here. And then we have a load, but why it's this shape? Because when you make the simulation, you are going to provide the non-linear. So if you put the R, it's just the sinusoidal load. But in reality, you have a non-linearity. So for this case, we provide this load like this one when you make the simulation. And this is the grid. And what is this? What? Filter. No. Source impedances. We call it impedance of the grid. So as much as the impedance of the grid is higher, the grid is more weak. Okay? So a strong grid has smaller impedance. Okay. So if we go a little bit with more detail, we see that, you know, we have a source here, we have interface converter here, we have a gate drive circuit here and pulse with modulation here. So we make the actually measurement from the grid side, load side, and converter side, make the control loop here, then give the order to the converter to inject based on what we need, not what we provide. We can provide, okay? So is it clear for you, Arya? Come here to explain if it's clear for you. Yeah, you say yes. He always say no, but when you should say no, say the yes, yes. Okay, like this one. Okay? I'm teacher, so I understand that sometimes you're pretending to say yes. Okay. But honestly, is it clear? Don't shy. We are learning together, so it's not expecting you say yes. Udaya? Yes, okay. Should I ask a question from you? Okay, good. I'm not that much brave. Okay. So, but basically, to make the controller, it's like this one. You have a car, you have a driving license, you know how to drive, but this car is not that you had. This is a new car, so you need some information about the car. And you need some information about where you are going to drive. And you need information how much fuel you have in your car. So for this case, we need information about the fuel or about the source that we have. And then this is my car. I'm going to control it in a way to inject power from here to here. Okay? So what I need is that where or what is the level of the voltage that I'm going to synchron my converter with it. So we need the information from the grid. So we get the voltage sample from the voltage for the analyze, for the control design. We need the information from the load also, how much power I need. If my load is nonlinear, so I should get the sample to see that this is a linear, nonlinear is a big load, a small load, what is, so the information from the load is important also. And then we need also information from the grid. So if my load is 10 ampere after control, so the converter inject 10 ampere or 8 ampere. So if it inject 10 ampere, it means that my converter is working well. But if it is not injecting 10 ampere, it means that something is wrong. Okay? So we also should consider the DC voltage here. Why? Because we are going to provide the energy from renewable energy sources. And renewable energy sources, the nature is variable, okay? So if we have a turbulence in the DC side, then it provides actually transfer these disturbances to the AC side. So we need the regulation here. So make sure that the DC is stable for provision of the stable also AC side. So we need all this information in the control loop to provide the right order for the control of the converter for injection power from a renewable energy source to the power grid. So, any questions so far? This is a 3-level converter, okay, so for this case. But doesn't matter, it's 3-level, 4-level. If it was 4-level, we had DC1, DC2, DC3, okay? So, but for a 3-level converter, the structure is like this one. We split the DC DC voltage to VDC over 2, VDC over 2. Yeah, then the importance of actually this topology is that when we split the DC voltage, so assuming that if we have a 2-level and the voltage is 6,000 VDC, so then VDC goes over the transistor, okay? So 6,000 drop over each transistor. But when we go 3-level, this 6,000 divided by 2. So the stress over the transistor is less, or we can increase the power to 12,000. So it means that we can increase the power of the input and inject more power to the grid. So this is why we use the multi-level converter. Multi-level converter has also some other benefit like less THT and this less harmonic, and also the filter is smaller, but probably is out of the, yeah. What? RST, which one? Okay, yeah, RST is phase, A, B, C, 1, 2, 3, RST, yeah. So, any other question? Arya? Yeah, you swear? Okay, so come here. Yeah, to explain everything. Yeah. Otherwise, look, you should invite for the dinner. This is not handling by... No, it's okay. So it seems that you got the point. Yeah. It was risky, okay? I mean, the difference between Finnish and Indian is that when you ask the Finnish, they can easily say no. Did you get it? No. Okay, but Indian, yes. Did you get it? Yes. I had some interview with some Indian candidate. So I'm saying that my group already, I have some of them, and I'm really happy with them. But some cases, actually, I see the CV, they mention everything. Then I ask something, I said that they have this background. But I ask that question, I see that no. But they never say no. Yeah. But don't be shy to say no, because here we are learning, okay? I'm not examiner, I'm your teacher. Okay. And I like you also. Yeah. You start taking a nap without actually shying, yeah, in the class. Okay, anyway. Any questions so far? Udaya? Okay. So now this is actually general, just a sample of the different applications. So you see that the nature of this technology is AC. The nature of this solar is DC. Fuel cell is DC. And micro turbine is AC. Energy storage is DC. And then we have also different types of the load. So if we are going to actually supply, we need some interfacing system. So we need a rectifier. We have a DSP controller to control the interfacing system. We provide a DC bus, and then we use the DC-AC converter to provide the AC for supply the load. So it is not that much complicated, but basically understanding of this concept is based on that what you have, what you are going to provide. So it's like how much money do you have and what you are going to buy. So it's a little bit different from this recording. Then I would say that it's difficult for the ladies, because when they go to shopping, they don't care how much they have. They want to buy everything. Okay, but I'm joking actually. So basically, this is the something. It should be understandable based on the generation and consumption. And if we don't have something which are not matched, we should use the different types of the converter to match generation with the consumption. Anyway, so for this case, you see that, first you need to see the nature of the generation and nature of the load. So now we have a concept, we call it microgrid. Does anybody know what is the microgrid and explain as easy as possible? What is the definition of the microgrid? Arya, do you know what is the micro? Okay, good. I mean, my idea is to say you can say no. Okay, microgrid. Does anybody can say I never heard this microgrid in all my life? How many of you guys heard the word microgrid? Shaking actually. So, you don't know what is microgrid? And you never heard about this? Okay, good. Yeah, this is good. So, assuming that you have a building, and thank you for honestly saying these things. Yeah, if I ask Arya, yes, I know what is microgrid. Yeah, but explain, I don't know. Okay. Anyway, I mean, assuming that you have a building, just a simple example. We have a building. So you can provide the electricity for your load in this building. Okay? So do you need to buy electricity from distribution line? No. Okay? So this is one example. And another thing. You have actually generation in your home and the grid is unstable. Do you prefer to buy the electricity from unstable grid, or you prefer to provide electricity for yourself from your generation? Which one is better for you? From generation, yeah? Do you agree? Okay, so the role of microgrid is this. We provide electricity for ourselves, and we have this possibility to isolate it from the grid when the grid is not stable. When we are talking is not stable, it means that, you know, I have electricity and grid is also okay, but it's in a peak time and I'm not going to pay for the electricity during the peak time, so I use my own generation. But the message is that this type of grid or building that I have or I'm living has this possibility to be separate or isolated from the grid. Okay? So this is microgrid is a part of the grid which can be connected or disconnected from the grid, or can be disconnected from the grid when we have some issue in the grid, and then can be connected to grid when the issue is solved. So when we have connection with the grid, we call it grid connected mode. And when we are disconnected from the grid, we call it isolated mode. So, or islanding mode. So it means that we have a generation and load, nothing with the grid. Okay? So we can provide electricity without having the connection with the grid. So just a simple example is here. So we have this possibility to be connected with the grid, and this is the load we have. We have an energy management system, but we have this building. We can provide the electricity from PV. We can actually use the electrical vehicle for charging and discharging. And also we have this diesel generator, battery, and flywheel, but we have also DC loads and AC loads. So this type of actually, so it's a combination of the generation and consumption. And we cannot say that, you know, I can connect my building to power plant and consider as a market. No. We use the local power generation in a smaller scale and provide all or part of our consumption. So just as this type of actually technology can provide more reliable. Why? Because it is disconnected from the grid and we provide electricity for ourselves. It is more resilience. If storm happening, something actually disconnect the transmission line, we can provide electricity from ourselves. It's more efficient. We have generation close to the consumption. It is more environmental friendly. We can use the PV, wind, and this type of local generation for that one. It is more secure, so it means that we don't have this distribution and transmission line. This attack cannot happening. It's easier to control because we have a generation close to consumption, and we can easily, if the consumption increases, we can just turn off one load and make the balance, but there are some other actually. Secure to issue occurring elsewhere, so it's like the photo I shown you. If fault happening here, several actually kilometers far from here also get affected. So by this technology, it is not somehow affected by somewhere else. So capital investment can be scaled over the time. So it means that after spending some money, it's returning back because you don't pay to the distribution company. Microgrid can be integrated into existing system. If the government lets you, you can provide electricity and sell it to the to distribution grid. And it can use the combined heat and power, like using the fuel cell, provide the electricity and heat, and after that use the heat for some actually thermal activity. So seems that this is a nice technology, and also we can use it different places. So some simple example is like here. So this is a microgrid in Sendai in Japan. So it's a combination of the main grid, gas generation, fuel cell, PV, and in this building, so if a storm happening, you have access to provide electricity for some sensitive loads. So it can be provided by battery energy storage to supply by the PV or fuel cell, and then use the conversion system to provide electricity for that. But the main interesting part is for the remote places, when you have actually some small village far from the distribution or transmission line. You don't need to somehow provide the new transmission line. So this is an example of the village with 638 population in, if I'm not, Alaska. So we have a diesel generator which provides 1.6 kilowatt, and also wind with 400. So by these two combination of these two generation, we can provide the electricity for these 600 people. Okay. So microgrid can increase the resiliency of the system, because when the storm happening, we can provide electricity for our system. Then the grid, if 1 week out of the order, you can also use that one. So if it's fine, we can stop here, then go to lunch, and then continue after lunch. Yeah? Okay. Thank you. No question? No? Okay. You're hungry? Okay, good. Arya, you're hungry? Okay, good. I mean, you're like sometimes yes, sometimes no, but depended the situation for you. Yeah? Very smart. Yeah, thank you. Yes. No, we see this one, okay? We see this one. A DG, yeah. Look at this one. This is your answer. Is there? Okay. I explain the next session. I can start right now if you want. I can, okay. So, okay. Mm. Mhm. Okay, let's see. If I feel that, Arya is feeling sleepy, then I stop actually teaching. You're hearing what I'm saying, yeah? Okay, good. He's in the bed? Oh, he's here. Yeah, okay. I say something about you. No, about the Arya. He's not here? He fall asleep, take a nap. Yeah, he deserves actually. Too active. Okay, yeah. Okay. Mm-hmm. No, this is actually this is the next part of the.
Oh, yeah, fine. So we'll start the continue the first continue the part of the what we have discussing, that is the DG technology and its application in power system. So that the session will commence.
Okay, thank you. Yeah, so we discussed about the microgrid. Was it clear for you? Yes? Yes or no? Yes? What is the microgrid? Tell me. As easy as possible.
It is a part of a grid.
Tell me. No, look at me. A smart grid is like a building. It provides electricity for the loads, can be disconnected from the grid or connected to the grid. Tell me. You're shying.
It is a type of grid which
Can be disconnected from the grid when we have some problem in the grid, and then again connect the grid when problem is solved. Yeah? Excellent. So, now it's clear?
Yes.
Okay, good. I normally ask the person that first say yes. Once say yes, I hear something yes. Yeah, okay, I get back to this. So, don't worry. Did you wash your face? Okay, I mean the teaching will be finished when you feel sleepy, okay? Okay.
I have taken strong coffee.
Okay. With milk? With you? It's cold actually. So anyway. So Arya, the previous session was clear for you?
Yes.
Yeah, what is the microgrid?
Yeah, just answer the same question.
Microgrid, I think you have not.
If you remember, okay, what I told him about him, I said that, when I'm teaching, he So, or physically in the class look at me, but his mind is somewhere else. So now he said that you didn't explain. Yeah, so, yeah. So, okay. You are not going to say something? Should I repeat again?
No.
Is clear for you?
Yes, yes.
So what is the matter?
How do I explain?
Yeah, tell me.
I'm asking you, how do I explain?
You can as simple as possible. Assuming that you know you are going to
Microgrid is like we consider a very small area
very small area.
for the generation, and it's like whatever is given it through it, it's for not for large amount of usage.
Okay.
Like in simpler words.
But this is distributed generation. This is not microgrid.
This is
Distributed generation source. This is not microgrid. This is a small area generating electricity for usage. Yeah? So it is distributed generation technology. My question is, what is the microgrid? So get back again the question. Was it clear for you?
no.
Okay. Should I explain again to you?
Yes.
Okay. Yeah.
I'll just grab my pen.
Okay.
Backside.
Are you ready to listen to?
Just have a seat.
I think he's the only son of the family, yeah?
No.
The brother?
Younger brother.
Younger brother. Poor younger brother. No, it's like a lovely man. He take care, hey, please do this one, supporting, this is why, not bad brother, it's good part. Yeah, okay. So, I mean, in some cases you don't need to memorize something actually. Microgrid is this one. No. You should understand that what is the mission of the microgrid, okay? So, we have power grid, we have microgrid. So you should recognize that microgrid shouldn't be big grids. Otherwise the name was not microgrid. So microgrid is a part of power grid. So what is the meaning of this? Power grid is generation, transmission, distribution, and consumption. So this building is consumption side of the power grid, but it's supplied by the grid. It's a grid connected load. So when we provide our electricity for our building, this building can be considered as a microgrid. Why? Because we provide electricity for ourselves. So we can be independent from the main grid. So microgrid is a part of the main grid which can be disconnected from the grid if something wrong is happening in the grid. And then if it was recovered, we can return back the connection mode. So for disconnection from the grid, we need to provide our electricity by ourselves. So it means that we have some local power generation which can provide electricity for ourselves, so we don't need to be connected to main grid. Is it clear for you?
Yes, no.
What is microgrid?
Microgrid is a system in which we produce energy in small, like not basically small, but for the household usage for ourselves, and we are not dependent on the main station.
Yeah.
So like it's for ourselves, and whatever the energy is produced, and it's not connected to the main main line, main transmission line.
New generation of microgrid. Yeah. Okay. Yeah, excellent. Thank you very much. Thank God also. Anyway, so I mean, basically, when we are talking about microgrid, and we need to understand the concept, because later you can work in this direction rest of your life. You can go forget this part, or probably you. And this is a very interesting topic that we need to know and have a deep understanding about. And the reason is that lots of, at least in European Union and lots of advanced community and countries, they are planning to reach carbon neutrality by 2050. So it means that we don't have any generation from this fossil fuel, and we provide electricity from different types of the renewable energy sources. So it is important to see that, if it is possible to support all the consumption by the renewable energy, or do we have any possibility to provide all energy from all consumption from this technology or not. So one aspect is that we provide electricity with the big wind turbine, and then we have the power plant, or solar, we have also transmission, distribution, and this type of things, and then support the loads. But it doesn't mean that we cannot use the other potential. So the concept of the microgrid is coming from this aspect, that you can provide electricity for yourself and support your own load. So this is important. But this is not that much easy that we define it. Because you can provide electricity, then reliability, stability, and security, and lots of other things are needed to be considered, and any of these targets can be researched for several years. So this is important, you understand what is it. But at the end of the day, you should clearly say that microgrid is combination of the local power generation and consumption, which also have the possibility to be connected to the grid. So now I have a very easy question. Considering this one, we provide the electricity, and with the inverter we provide the power to the load. So if we disconnect this grid, then provide the electricity for the load, is it microgrid or not?
Yes.
Yes. Why?
Because the energy generated by the solar panels are basically getting used at home appliances and other devices.
Yeah.
Though it is not getting forwarded to the MSCBs.
Oh. Do we have any constraint for the microgrid or not?
Maybe the high power appliances won't
May
work.
can damage the devices.
What?
High powered appliances won't work. Maybe that can be a thing. Or maybe it
Yeah.
won't be for working for a long time. If all are working, it will be consumed in a very short time.
Yeah. It can be some constraint or existent, or some solution are also existent, but this is also true that sometimes generation is less than consumption. Yeah. And what is the interaction with the power grid? Do we need to have power grid or not?
But like you said that it is disconnected, right?
So if disconnected, then we should consider this source. Okay? So we said that we have residential conventional PV system grid are not microgrids, but they are distributed generation sources. And the reason is that if we disconnect the grid, it doesn't work. Because they have synchronization with the power grid. So if we disconnect the main grid, it means that the voltage is zero, and this converter, the output of the converter will be zero, the voltage, because it provides a reference based on the grid. So for this reason, this is not a microgrid. This is distributed generation technologies. So for the microgrid, when we use the local power generation, it should have a functionality to react as a voltage source. But what this works is like a current source. We call this type of technology grid-connected operating mode. So it means that when it is connected to the grid, it works. But that one I'm going to talk later is grid forming. It means that it can act as a voltage source, not current source. Okay, so this is a difference. So if you see this one later, and as this is a microgrid, you can say, okay, depends. If the controller is designed in a way that if disconnected, then it can continue, create the voltage point at the output of the converter. This is microgrid. Otherwise, it is grid connected distributed generation sources. Okay? Did you get it 100% clear? So. Okay. Yeah.
The load cannot be powered even when the sun is shining.
Yes.
Even you have a lot of PVs connected.
Yes, because it cannot be, because it cannot work like a voltage source. It cannot create the output voltage. It has the current control. Yeah. So let me explain in a more clear way.
It's like load is huge enough.
No, this is not because of that. Okay, good. Yeah, it makes sense actually. Okay, so this is a converter. Okay, so this is a DC bus, and this is the output. So we have a filter and transformer. So we make the equivalent. So I will ask after this explanation. Okay, so pay attention carefully. So we inject the current because the voltage is fixed here. So S is V times 2I. So we can create the power. Okay? But this voltage is fixed. And accordingly, this voltage is also fixed. And then the current changing, so we can play with the injected power. So if voltage is 10, then current can be 2, 3, 4, 5, and the S can be 20, 40, 60, and okay? So we can control the current, so by this, control of the current control loop, okay? So it said that, based on I need in the grid or load, so I can give the order to the converter and converter inject. So for example, if you have I don't know, this is the grid and this is the load, and load is 10, then I make the measurement from the load and say that please tell Mr. Converter inject 10 ampere and converter inject 10 ampere. And then I change the load again and the load current go to 20, and I said that now inject 20, 20, inject 20, okay?
Voltage is constant.
Yeah, voltage is constant, yeah. And the controller is coming from this voltage of the grid, okay? But when outage happening in the grid, voltage go to 0. So then it doesn't provide reference for that one. So you cannot provide it, it goes shut down. So for this case, when we use the PLL, does anybody know what is the PLL? Okay. What is the phase lock loop? What is your name? Anirudh. Okay. So what is the PLL?
In which we phase lock loop in which we check phase difference between
between different. Repeat again your name. Anirudh. Okay. My target student, Anirudh. So okay, but thank you very much. At least this is not expecting from the bachelor student to know. So it seems that you know something good. So phase loop, okay, is like this. So I get the P, use the PLL, and then in PLL we have the voltage of three phase. Okay, then the output will be frequency and theta. Okay. So by this, I can control my converter and say my converter that when you synchronize, it should be in phase with the grid. Okay. So for example, if the grid current is like this, okay, and in this time 46 degree, for example, you are going to integrate your converter. You connect your converter to the grid and inject 10 ampere. So if you connect, it should be this match with this degree. So it's like this one. Okay? Otherwise, it makes some unbalanced situation for that one, because then it is not matched. So assuming that we start from here to here. Okay, so what happened here? Here current is negative, here is positive. So for example, 10 ampere is the grid, minus 3. Instead of having plus 3, we have minus 3. Okay, so it makes the problem. So this PLL provide the theta for us, the instantaneous angle of the grid, and say that when you connect to the grid, you should be matched with this, so your starting point is I max sine omega t plus theta. Okay? So you get this theta from PLL. So if these things happening, it means that, when you have this converter and grid goes to outage, in fact, we have no reference for the PLL, and then PLL give the 0, and then it goes shut down. Okay, this is the problem. So they have some solution for that one. We see later. Okay, good. So is it clear, 100%? Nobody say yes. Oh. Yeah. Okay. Doesn't matter. Okay, I can speak Spanish, Danish, English, Persian, Finnish. So today probably if I decide to stay in India, in 1 year probably I speak Indian. So you're here, you try to maximize your knowledge actually. And if you know these things, so why you are here? We learn together.
Do we need a neutral?
Okay.
If we remove the neutral, then that's the reason that it doesn't work. Is it that?
No, I mean the control is dependent on the voltage. So this is the reason. But what you mentioned is also important part in the control of the converter. I mean, because when they go to the unbalanced situation, with most of the situation is like this one, it is compulsory we have. Otherwise, some problem will happen. Okay, I was in a conference. I had a presentation about the three-phase system, and there was a very old nice gentleman. And then he said that I have a question. And he was very angry with me and said that, so if you don't consider the neutral point, then what happens if fault happening, if unbalance happening, if this type of thing? And then after lots of explanation, I say just one sentence, this is for the balance system, just like this one. And then he started the presentation. And he left all the people and just look at me all the time. If you don't consider this problem happen, if you don't consider that problem happen. I said, okay, thank you very much. And during the conference, when I was in the, for example, coffee room, and he just said, like this one. He was very angry with me. I said, okay, please, I made a mistake. Okay, but he was a very famous person also. And this is why I said that, what you are mentioning is completely correct. And then the other point is that one engineer should be stupid if he doesn't consider this neutral point or grounding or this type of things. But when we are talking about the design, it's different story. Yeah. Yeah, assuming that we consider that one. This type of things. Okay, any question? Was it clear for you?
Sir,
Yes.
PLL can track theta in every situation.
PLL?
PLL can track theta in every situation.
PLL basically is very sensitive to the disturbances. So this is the weakness of the PLL. And normally there are some other methods that you can use. But probably I can explain what is the mathematical equation behind of this. You want me to? I mean, basically it should be, the amplitude should be equal with the reference voltage. But you can consider periodic value also. And if something happening, it makes a problem for them. And if the system is polluted by the harmonic or unbalance issue, it even makes much more worse. Okay, so, and the idea is that when we go inside the PLL, Arya?
Yes.
Do you know what is PLL?
Phase lock loop.
Okay, can you explain with the
Shall I come here?
no, calculation?
Calculation?
Yeah.
Like firstly.
Yeah, how we reach that one?
Pardon?
From voltage to.
You want the equation, sir?
Yeah. I have 1,000 euro, then I'm going to give to you. Yeah.
Depending on the load, the feedback
No,
is
you should think by yourself, not listening to the wrong person. Okay. So this is the phase, okay? VA, VB, VC. So basically, we have a clock which we provide V alpha, V beta. Okay, you probably know, but we get back to this one later. So if you don't know what is the Clark transformation, just don't worry. So we transfer from 3-phase to 2-phase. So it is basically VA, VB, VC, okay? And it transfer to V alpha, V beta. And then the reference is changing based on the V alpha and V beta. So PLL give this one, theta. Okay. Theta is equal to tangent inverse V beta to V alpha. Okay? So anything changing, the value of alpha beta changing, the theta changing, and the controller will be subjected to this change. So this makes a problem, and honestly what the controller of, and then for this reason the interface converter also gets some turbulence. Okay? So this is why the weakness of the PLL is that any disturbance happening, it getting the problem situation. You got it?
It requires minimum voltage level.
Minimum voltage level.
Or threshold. If it requires threshold,
No.
how we can set this?
Yeah, actually, the question is a little bit tricky because if you have the minimum voltage, it means that you don't have a stable voltage. So when you don't have a stable voltage, then PLL cannot be useful method for that one because it provides instead of providing actually the angle like this one, it provides like this one.
In distribution level, 0.6 or 0.7 kilovolt can be also stable.
0.6 and 0.
In distribution level, not transmission level.
So what is this? Read it again.
In distribution side, 0.6 kilo or 0.7 kilovolt is also stable.
Stable. So you are talking about the SCR, short circuit ratio? Yeah, correct. I mean, what you are saying about the stability of the grid, okay? What you ask is different. If you are going to consider the impacts of the PLL and voltage on the PLL, then is there any standard to say that this 0.7 can be also considered?
I was asking when you said if we convert VABC to VDQ, is there any requirement for minimum level of VABC?
I mean, we converted from ABC to DQ, okay,
Is there any
but
requirement?
yes, okay. When we talk about the requirement, it means that, we cannot neglect the V0 also, homopolar. Because then if we consider that it is something that we have a threshold work that one, it means that then the 0 point is not equal to 0, so you cannot neglect it. Then you should consider also another wire for that. But if you say that there is something, I really don't know. It depends on the code of the country or how you. I have no idea about that. But I know that it doesn't work if you consider just DD and DQ. And I bet with you, if it works, I give that 1,000 euros to you. Okay? So, any questions so far? No? Microgrid. I mean, basically, this is a definition. This Robert Bob Lasser. This comes in Madison. He provides actually suggested this one. So, but I think the reason is that it's for the small scale, but and it makes sense also. I mean, you can call it non-grid, grid, anything you can, but then it should be somehow, you should be too lucky if the people accept it or reject it. I mean, basically this idea started from this Bob Lasser from University of Wisconsin, Madison. Bob Lasser. Yeah, I mean, at least he was one of the first actually started this topic. And then if you go with Joseph Gorado, you probably have more than 1,000 applications just in one. This way. For microgrid, I mean, basically the concern of the microgrid is not the power or voltage. The main idea is that how we can, or the main contribution is that how we can provide electricity for a region that we have no access to distribution. So it's like working as an island mode. Then this is there. And then it depended what kind of load do you have, if it is big load or small load. Even for the big load in the remote place, it doesn't make sense if you have a 10 megawatt power. Then you make the 100 kilometer transmission line and go there. It's very expensive. So the idea is that we use this technology to provide the electricity for a point that we have no access to the yeah. I mean, it's a little bit tricky, but one of the most small one is a laptop. It was like 5 ampere for the loads. Less than 1 kilowatt, I did in my lab. So this is my answer. I actually saw it. Did you get it?
No, I was not actually. We were discussing.
Why you are talking?
Sir, actually.
The question.
Yes, actually, we had a doubt.
You are explaining to him?
No, he was telling me.
Okay.
Actually, we were discussing a point.
What point?
Sir, it was point out if there is a DC main supply, if any country is using the DC supply, then it would be the microgrid now. There is no.
I mean, microgrid can be DC, can be pure DC, can be.
No, but what he's saying that if any country is using DC, is there any country which is using DC as primarily, so that there is no thing of microgrid, like it will be considered directly as a microgrid, right?
There would be no use of inverter.
Then there is no need of inverter, this transmission lines as well.
I mean, I didn't say this thing, but this DC, there are some actually DC distribution line with 48 volts, something like this, which can provide electricity for the DC loads. But then it is somehow high demanding, and they said that nowadays Edison model is much more feasible in comparison with the Tesla model.
No, but about as it is the distributed generation now.
What we are talking is that can it be used individually for house?
Yes.
DC?
Yes.
Fully?
Yes. But depending if you have AC or not. But my answer to you is like this one. If you listen at the beginning of his story, he said that we didn't like the Edison model because we didn't have power converters. So now assuming that in your home you have also AC, but DC model is better and can be as a source for the AC, but because we have the converter, we can convert it to AC and use it. Yeah.
So according to our preference, we can.
Yeah, it can be, and it's something that still they don't know that it is better that we shift from AC to DC or not, because lots of loads are nowadays DC, and then transferring even for the transmission line is much more better to go by DC. So yeah, HVDC system, and basically if transmission line is more than 80 kilometers or 50 miles, it makes sense go by DC instead of AC. So it means that you convert from AC to DC and then go by DC and then DC to AC. And do you know why 80 kilometers, more than 80 kilometers?
Power loss.
Resistance.
Cost. Cost. Yeah. Yeah. Sorry, I didn't hear you. Yeah. Yeah, cost is important. Yeah. Basically, when we are going to use the HVDC system, then we need the rectifier and converter. As you mentioned, we should pay for this conversion system. So assuming we have an AC and DC. So we use AC, but it have the induction losses. Okay, because Z is in cable Z is R plus JL omega. So we have this voltage drop and losses also. But when we increase more than 80 kilometers, the power which can be saved the price of the power is more than the price of the converter. So for this, if you have a long, more than 80, so it economically makes sense. We use actually, we buy the inverter and convert it to the DC and then transfer it to AC at the end. So this is the main reason that HVDC is more feasible when we have actually, we are going to go more than 100 kilometers. But basically when we are talking about HVDC, normally something like 500 kilometers is very small scale. Sometimes reach to 3,000 kilometers, something like this. So we reach from distributed generation to HVDC. Now my question is that, is it DG or microgrid? DG. Why?
Because like we are considering both. So it, like actually we are considering this as well. So that's why we cannot consider it as a microgrid.
Sir, microgrid is that we can connect or disconnect. But here we can't disconnect. If we disconnect, it would not work.
Yes. So if we disconnect the grid, it cannot continue. Why? Because it cannot provide the voltage reference for the converter, and converter work like a current source, not voltage source. So, any question so far? No? Is it clear or complicated or clear?
Sir, suppose you are going to use inverter like home UPS inverter is there. Home UPS inverter is there.
Yeah.
That is there we are going to enter to the kilowatt reference.
I mean, when you talk about the home, it depends on what kind of technology you use and where is your home. Your home is here or your home is remote place. If you go for home in remote place, then the converter should work like a grid form. Yeah.
Suppose you are going to use the renewable energy source that is only used for our home beside it.
Yeah.
We can consider it as microgrid.
Yes, definitely. Yeah. Yeah. Because you have actually coming to grid also.
Abstracted in the isolated.
Yeah. Yeah, exactly. Because you have the measurement. Yeah, you have measurement for the grid also. Because when you go to isolated mode, still you have access to because otherwise when you return back to the grid connected mode, you cannot be synchronized with the grid. So you always need to be actually you have the measurement from the
So
grid.
the rural area legislation is there.
No.
They are going to use only solar or wind.
Yeah.
That is only using for that equipment what we have at that place.
Yeah.
We can consider it as microgrid.
I mean, you can consider if your model is working like a grid form, like a voltage source, grid forming. If it goes for grid forming, no, it is teaching. Yeah. Because you cannot actually supply your load.
There is no possibility of connectivity.
Yeah. So it is not grid.
There is no gridding is there. Only that the renewable energy source is utilized for all the weather station is there, whatever it will be. I'm using that energy generated as well as that is stored in the battery. Utilize the complete energy to that weather station, whatever it will be. It is not connected to the
Yes.
You can carry in the system as a microgrid.
Yes. So let me answer to your question by a question. Can you supply your load by this PV or not?
PV.
You can. Okay, it's fine. Because if you, it's come back to the control aspect. If your controller is designed in a way that your converter can act as a voltage source, it means that it doesn't need to be connected to the grid and provide the energy for the load. It is microgrid. Okay. So, any question? No? Yeah. Any question?
Sir, for many of the industries or from the dam where the conversion occurs and we create the energy, these are transmitted hundred of kilometers or more than that. Then they are transmitted by DC supply or AC. Or is there any conversion system between or the transmitter in between? They can supply for the longer range.
Yeah, they have this multi-terminal HVDC system. So it means that you can create 3,000 lines, 3,000 kilometer lines, but you can be connected or disconnected in the middle.
No, but like how is it maintained for such long? As we said, it is 100 kilometers or more than that.
So how to maintain it?
So like, do we use any converters or something in between in the grid line?
I said that, yeah, if you consider this one as a multi-terminal, yes. Because for example, sorry? Yeah, I mean DC to DC is one, modular converter is one, and then yeah. Yeah, I mean it depends, but if I'm going to just simply say that, you are going to, for example, connect the HVDC system to load between the beginning and end. So then depended that, it's a AC system, DC system. So you don't need to have a DC system and then DC DC and then DC AC. So you can provide actually this type of different technology that convert DC to AC. But what you said is that from here to here is 1,000 kilometers, okay? So we have a rectifier here, change the AC to DC, and we come here, we have a DC to AC converter. Up to here is clear. So in, for example, middle, there is a village that they need the electricity. Or there is some power plant that can provide the electricity. So then we have also this type of conversion system that change it and then provide the electricity or inject. So this is called multi-terminal HVDC system. So it means that in middle you can also provide that. Yeah. If you look at that one, why are they not marketed? Because they cannot operate isolated from the grid. Yeah. Yes. In grid following technology case, grid following or grid connected? Don't know. Do you know what is the difference between grid following and grid connected? I'm assuming you feel that they are the same, yeah? You think that they are the same, yeah? Or they are not the same? Do you know what is the answer? Please no more. Okay? So, Arya, do you want me to stay after class actually answer to your questions? Yeah, then we can go see your hobby. Yeah. Okay, ask final question.
So actually the question was that, like, as you said that if it's disconnected from the main transmission line, if the appliances or anything won't work inside the home. But like in our case, like considering
light goes off,
like electricity is off or it is turned off by the main station, but still some of the appliances will be working.
Oh.
Like
inverter.
I said that if your controller is in a way that your inverter works as a voltage source, it is possible. But this one is not voltage source, this is current source. Because
but we can store in the batteries and that we can use it.
Yeah, battery is like a voltage source. Battery have a constant output voltage.
If we connect the battery inside this, then it can be the microgrid.
If you have a DC, only DC.
No. We can store the energy of solar.
No, the problem is that you cannot create the reference voltage in output of your converter, independent from the grid. This is the reason. You didn't get it, yeah? Because you are not listening to me. You listen to this man and then you actually make the confusion for him and for yourself. Okay, so I tell you one time for the rest of your life. Okay, it's depend to you are trying to get it or not. If you are going to have a converter to provide electricity for load, you need to meet two criteria. So first, control the current. Second, the control of the voltage of the converter. Okay? But when you have a connection to the grid, you don't need to control the voltage of the converter. Why? Because you have the reference from the grid. Okay? So, in this case, when grid is shut down, it means that you miss the reference. So your reference will be zero value. So it means that the output voltage of converter is zero. Doesn't matter you have lots of sources. Your converter is like a zero value actually. The output voltage is like a diode converter. Okay, so it doesn't work. So this is why if you are going to work in a independent from the grid, you need another level of the control which say that second control level which control the output voltage of the converter. So it creates the reference for the output voltage, and this converter now working like a voltage source. So in voltage source, you have a voltage, and this is a constant voltage that can provide electricity I for the load. Okay? But in this case, it is not like this. Okay? If I was the examiner for this course, I ask this one. And if I get a little bit if or else, I easily give the zero to Ari. Because he was the main problem maker in the class. Yeah. Okay. Is it clear? Yes. GV or current source. Okay, yeah. No, it's actually when we have the wind turbine, again, the matter is not the source, the matter is the interfacing system that is controlling grid following mode or grid connected mode or grid following mode. Yeah, you will see this one. So, except this guy, does anybody have any question? No? Okay. So it means that you got it, okay? Should I ask a question? Some of you guys come here and explain it. So, no.
Cost.
Okay, anyway. I hope you get it, but later if you don't, just ask me again. So this is not microgrid, this is distributed generation system, because if we actually disconnect this one, it cannot support the loading isolated mode, like a islanding mode. So now we have the distributed generation, then microgrid, now smart grid. So now I would like to know that is there anyone can say that I never heard about the smart grid? Okay. Then is there anyone to say that I know what is the smart grid? No. So only Somi knows what is the smart grid. Yeah? You guys really don't know what is the smart grid? You know it? So why you don't hear it? Do you know what is a smart grid? Yeah? What was your name?
Siddhant.
Siddhant.
Yes.
Siddhant?
Yes.
Am I pronouncing it right? Siddhant?
Yes.
Siddhant.
Siddhant.
T. It's T in ending.
Siddhant.
Siddhant. Yes.
Siddhant.
Yes.
Okay. Siddhant. Do you know what is the smart grid?
Sir, actually during our practical, I had heard this concept by our faculty.
Mhm.
Right now,
He's trying to pass this. If I'm wrong, this is the. Okay, sit down. Yeah. Tell me what he said or she said.
That was 1 year back. Concept.
You forget. Okay. I'm confused. Yeah, you don't. Yeah, I don't know. Okay. Thank God. Yeah, I was explaining actually. Tomorrow again get back to explain and okay. So tell me what is the sit down.
Actually, in the microgrid, we have distribution generation as well as the load is there. The load demand as well as the distribution generation. Here by using the measuring technique, metering or measuring, and here we get the information from those sources, from the generation side as well as distribution side, where it is required, where to produce. All information is controlled by a centralized control or distributed control line.
Okay, great. What? Yeah. Okay. So
Network that communicates with the power outages, with the supply.
Yeah. Any other? Yes. Okay. Can be. Yeah.
It has some intelligence too. It is having communication between the generation as well as load. In between the generation.
Okay.
Can provide some intelligence to the grid.
Intelligence for the grid. What kind of intelligence? So, I mean, your answer is like that. What is the smart grid? A smart grid is a type of grid which is not stupid. Okay? So, tell me. You have very something. Yeah. Exactly what I actually here. A smart grid is a type of grid which can communicate between the generation and consumption. Okay? So it means that in a conventional grid, we said that always one of the weakness of the power grid was that generation must be more than consumption. Otherwise, the problem or outage will happen. But in a smart grid, we communicate between generation and consumption. So it means that we have this possibility, if generation is not enough for the consumption, we'll optimize the consumption. So assuming that, for example, you're going to use the dishwasher. So you put this dirty dish in dishwasher and close and push the button, but it doesn't work. Why? Because the load center knows that now is 8 p.m. and the consumption is high. So you turn it on, but it doesn't work. Why? Because then they transfer this load to 11 p.m. when the actually load is not high, consumption is not high. So it can communicate. So we have different level of the control. So control of the component, control of the system, and control of whole network. So, for example, you can control the operation of your fridge, your dishwasher, your clothes washer. You can program it, and program is coming from the one central hub, which communicates with the distribution grid. So this provides the information between the components, price, everything, frequency, voltage, everything related to the network, and then say that, okay, you turn it on, but please wait until the off peak. So it makes the balance between generation and consumption. So especially nowadays in this electric vehicle are so popular, and then you know this like for example one car like in Nissan Leaf. Yeah, when you plug in it takes 60 ampere. So do you know what is the 60 ampere? Yeah, you should put you in the middle and then get the barbecue. Okay? Yeah. So then okay. Then assuming that everybody has electric vehicle and they are coming to home 5 p.m. plugging, then it makes a big spark over the grid. So this is not something, it makes an instability for the grid. So for this, the charging station in your home will be a little bit more smart, it communicate with the network and also provide some things for you like awareness that if you are going to charge this one, you should pay 2 times. It is better by transfer discharging to I don't know 1 a.m. or 11 p.m. something that the stress over the grid is less. So it is much more better that you reduce. So this type of communication creates a smart grid. So in a smart grid we have 3 main parts: grid, consumption, smart loads, and also local power generation. So conclusion, distributed generation technology can be part of the microgrid, and then microgrid can be part of the smart grid. So by this, we can actually provide the economical benefit from the customer point of view, and we can also increase the stability of the network that we are using the electricity from that. So, this is the general structure of the distributed generation technology and grid. So, if you look at this part, you see that we have the building, we have local power generation and consumption. So we shape actually something like this as a microgrid, but in all together they are part of the grid. And the idea is that we provide a balance between generation and consumption. Even the consumption is not less than the generation. So this is the difference between the smart grid and stupid grid or conventional grid. So now I'm going to provide assignment to you and then looking for the best solution with 1,000 euros actually price. So now we are going to provide electricity for a community. Okay, so assuming that we have electric vehicle, we have storage devices, we have PV panel, we have then lots of stuff that you use for the daily life, and then now we are going to provide a smart community which provides benefit from the customer point of view and from the grid point of view. So what is the best solution for that one? So you have sometimes in peer group or tree, you can actually make something and present here. And then the winner will be very rich. Okay? So, take your time, talk together, and then design something that I see. Okay? Look. You already lost the 1,000, but I say again. So assuming that you have a community, you live in, it can be university, for example. So then you have different types of the storage, then PV, electric vehicle station, and then your this possibility to be connected to the grid and disconnected. But what is the best solution to provide a smart community? Yeah, you can present something and later we see that, yeah. Okay, my advice to you is that before you find, actually you write something, try to share the idea together, think a little bit, then share the idea together, then provide the solution. This is not something that you remember, okay, I can do this one, that one, okay. No. Just try to communicate in a teamwork and see that what will be the best solution for that. Okay? And I have it something in my mind. Honestly, if you answer this one, I will be really happy to see that you notice this point. Okay. What? I don't know. Okay. I said that from customer point of view and from network point of view. So what is the best solution? Yeah, both points. So then we see that what kind of service you can provide for the grid and what kind of service you can get from the grid. You're going to person? Yes?
Questions are the best way to solve them.
When you start the discussion, then you should stop it, then people are
Or everyone has their own equipment, like purchased equipment. They cannot shift to a new technology or new equipment, right? So you have an existing grid, which is already an AC grid, right? So AC grid, in that case, you can connect distributed networks, right? Distributed generators, right? And those should be connected to the AC grid. That's what I find a solution. And the second solution for the smaller community is a DC grid where the community is very small and you have a chance to replace the equipment which works on DC. Basically, most of the applications runs on DC. So there we can generate, like we can provide DC supply itself through the grid, right? And even we have some grids over there which are DC grid itself, right? And it's easy to connect those grids because it's a small community and there is no burden, huge burden to replace the equipment, household or any different types of equipment. That's my solution for both.
Thank you. And what is the role of the, for example, storage devices and electric vehicle, this type of thing?
Then obviously in AC grid we need converters and those are already available for electrical vehicles. So those all stuff comes under AC grids. Even in DC, that's a solution. Only you have DC requirements and you have DC grids. And storage is DC. Storage becomes storage. So for small communities, DC is better.
Yeah. So do you believe that, for example, one day we reach in the point that for example, in this university, they have this possibility to use the electric vehicle as a source of energy instead of the load.
DC.
Yeah.
Yeah, DC grid.
Yeah.
Like I'll give an example of my college, what I did, like what our college did. We installed PV cells, right? And we have generated 48 volts DC voltage for whole campus, for our whole campus. And even the SMPS of computer we developed ourselves in our R&D. The fans regulator, sorry, the BL, we use BL DC motor for fans. It's around before the 2018 we have did this, 2015 to 18. We shifted our whole campus from AC grid to DC. Our campus.
Yeah.
So that's what we know the things like DC. If you supply DC, it's very better. Like changing SMPS of computer is very difficult task, but we did it that way.
It's excellent idea actually. It started first at Illinois Institute of Technology by this Charlie Muhammad. He actually made this idea in the campus, and they reaching the point that they isolated whole campus from the grid. Yeah. And one important aspect was that they provided the local charging station.
Yes, we have a charging station also,
Yeah.
which is connected to that
Yeah.
EV charging station.
Yeah, this is excellent idea. Okay, thank you.
So when you start from a small institute, you can have, like you can make it bigger.
Yes, yeah.
Like it is inspiration to all of us.
Yeah, but they spent $15 million for that one.
No, our is very less. We got around 20 lakhs for this from government, and we experimented that.
Excellent idea. Thank you very much. Yeah. So, come in. Come in.
Sir, from your question, here the grid is benefited as well as the consumer is also benefited. Okay, here PV is there.
Yes.
And here I am going to get forecasting, weather forecasting information. As well as here I have battery storage as well as EV. And also it is connected to the grid, to the bidirectional inverter, as well as the load is there. So here I am going to plan the information we have from the grid as well as battery as well as EV and weather forecasting. Here I am going to charge my electrical vehicles in the community when it is in off-peak time. So the cost is also very less compared to the peak time. At that time I am going to charge it. So the burden, if suppose I am going to charge my EV vehicles at the peak time, it is burden on the grid. So here I am going to plan, I would like to charge my electrical vehicles in the community during the off-peak time. Okay, as well as here I have information about the weather forecasting. Also I need to plan according to that.
Okay.
So as well as I am going to plan my journey. Because I would like to go from my home to office, or office to home. The energy storage required to me is very less.
Yes.
40% of the SOC is enough. That is, I am considering that is critical for me, for my EV vehicle. What is the extra energy stored in the EV vehicle? That is, I am going to supply it to the grid during the on-peak time. So here I am going to supply the energy to the grid. Here I can earn more. So that is benefit to the consumer.
But do you believe that it's better that you sell it to the grid or use for your own load?
Sir?
You have a storage, okay?
Yeah.
Can be vehicle or separate storage. Do you believe it is better you use it for your own consumption or for the selling to the grid? Which one is better?
For on consumption, I have a battery system is there. I am utilizing the energy stored in the battery for my home appliance purpose, and the extra energy stored in the EV vehicle, that is supplied to the grid. Because I was stored energy from the grid or PV during the off-grid time, the charges is less. Here I am going to supply to the grid when the charges is high.
So you believe that, by using the storage devices, we can get the maximum benefit. Doesn't matter, I mean, sometimes charge or sometimes discharge. Yeah?
Yes.
Without storage, it is...
But here we have the weather forecasting information.
Yeah,
that is fed to the microcontroller.
Yeah.
It is going to operate with respect to all the information that is we get from the battery storage as well as the EV storage, the PV generation, and the load demand during the time. All the information, it is going to operate. Whether it is going to deliver to the grid or it is charges from the grid or charges from the PV, it is completely going to operated by the controller in the smart grid by using that entire information.
But what if, for example, because we have some constraint regarding the downgrade the actually operation of the storage devices in the vehicle or the price of the storage devices, or most of, sometimes also the forecast is not correct. So these type of things cannot guarantee the 100% reliability. But basically, idea is using the storage is somehow very interesting. But now European Commission goes toward using the PV for more than the storage in this. They said that we can use the storage. This is something which is important, but the PV is really the role of PV nowadays is highly attractive, and they are going to use PV everywhere. So just a simple example that nowadays they are going to integrate PV with the vehicle, they are going to integrate the PV with the charging station, they are going to integrate PV with the power grid, home, everywhere, okay? And India is the place that you must do it. But anyway, thank you very much. Excellent idea. Thank you.
Actually, suppose we are going to use the PV, the peak time is around evening 6 to 10. At that time here we require more load to supply with more load.
Yeah.
So when we are charging in the daytime, we can utilize this to supply to the grid. We can reduce the burden on the grid at that time. At that time, the grid is benefited from these setup.
Yeah. And one concern is that when you are interacting with the grid, charging, discharging, this type of things has some losses, and then you buy and sell it, then it is not 100%. You cannot get the benefit. So you should be. One aspect is to use for your own consumption. They have the same meaning, because even during the peak, if you sell it, you can only sell the extra power, because you need for your own load also. But anyway, thank you very much. Yeah. So, any other idea? Arya?
We have an idea, sir.
You have an idea?
Yes, sir.
Good. You were out of the class, so
No.
you made it. Okay, come here. Tell me what is your idea. I'm eager to see your idea.
Siddhant. Yes.
Siddhant.
Yes.
So, sir, the idea was like that. Firstly, we will be considering the AC grids, that is the power station, for daily.
Okay.
Then we are considering the DG, that is the DG distribution source, for the smart grid, and through the smart grid, it will be passed on to the EV charging station.
What do you mean by a smart grid?
Smart grid is like it detects the whatever the requirement according to the detected requirement, the output is given.
Okay.
So like considering the EV charging station, the load will be variable. It won't be constant. Like maybe at the evening time the load will be more, in the morning time or at the non-peak time it will be less. So depending on that, the smart grid will decide, and the power will be passed on to the EV charging station. Then we have used the PVC panels as well, which will charge the battery, the power supply battery, the different battery. and this battery will be used for other stuffs as well as daily appliances. So if the daily appliances can be used using this battery, which we have, which we got the power from PVC panel, the PV panels, it will be used through the battery. And if the battery is drained out or something like that, or if it's sensed like that by the smart grid, then it will shift to the AC grids, that is the main power station, and daily appliances will work on that. So like we are trying to minimize the use of AC grids using the smart grid system, using the batteries, and for EV charging station as well, we are using the smart grid, so it can detect for the peak time, more power can be drawn out.
How would you like to minimize this?
Like we are using various sources, like that is wind energy, renewable sources of energy, wind energy, or using PV panels. And you showed the example of a smart PV panel, like according to the direction of the sun, it will change the direction of its own to take the sun. So we are using that thing, like the PVC panels of that type.
Okay, is excellent idea. Yeah, I like it.
But like, do you like? Didn't you get it, or like it's fine?
I mean, what I'm looking for is that you said that maximize or minimize something. Can you show me by equation?
Not by the equation,
okay,
sorry.
Good. So you were close to 1,000 euro, but now it's zero.
Okay, no issues, sir.
Okay, excellent. Thank you very much. Yeah. So any other different idea? No? Good. Okay, please. You're getting close to the answer and I get stressed.
Okay, so the first method, what we can do is, we can add the renewable part in the grid.
Yes.
And besides the renewable part, we can provide a support of the battery, so that we can define the average consumption that the conventional power supply gives. So let's say if the conventional power supply gives me around 100 megawatts on an average. So what we can do is we can use the battery, means it can switch between the batteries and the renewable source. So like we have defined that we got 100 megawatts of power supply from this part. And the remaining power supply we can use the conventional ones, because it's not, means in the current situation it's not feasible to completely go on renewable. So we can use the conventional as a support part for the power supply. And what we can do is we can request the users, means whichever users are going to use the power supply, we can ask them two things, that if it is feasible, we can ask them to store a battery for it, so that whenever the high demand time, they can switch on their own battery, and during the low demand time, they can use it from the grid. And one more part we can do is we can use the ask the user to use PVs, photovoltaics, means the solar part, and if they have extra power with them, means if they on an average if they use around 8 to 10 watts, we can ask them to supply the remaining power on the grid. And the means this way what can happen is it will look like they are using more power, but on the grid there will be less stress.
Can you show by equation to me?
Sir, means which equations exactly?
I don't know. What you mentioned, it should be implemented, and implementation is coming from the equations. Yeah.
Sir, means like, can I give just a rough part?
If you don't like, it's fine actually.
Okay.
Udaya, you want to pay or I should pay? Okay. Yeah. No, 1,000. I told 1,000, didn't say 1,000 euro, dollar, rupee. No,
No, I pay 1,000 euro. Yeah. I should bring actually. Mm-hmm. So tomorrow we start from the equations, calculations, okay? So if you miss the session, then I think rest of the session are somehow linked to these sessions. So be careful to be on time. And if they make the delay, they really should buy something. Yeah. Tomorrow, chapter 4 will start. Yeah. Okay. You can start by a storage and then I go for that one. Okay. No, it's fine. The important is that we meet what we promised.
Okay, so what I basically did here is I've taken just 3 users.
Mm-hmm.
First user, let's say it's just the home appliances, a single house.
Mm-hmm.
In this part, it basically it is generating 10 kilowatts through photovoltaic, and what is happening is it is using 3 kilowatts. 3 kilowatts it is using. So what it can do is it can pass on the 3 kilowatt to the grid.
Okay.
And suppose I have the second user. Let's say it's a big company.
Mm-hmm.
It is using 5 kilowatts on an average, and it is generating 500 kilowatts, whereas it is using 1500 kilowatts on an average. So this will be taking around 10,000 kilowatts from the grid. Whereas the third user, it is straight away taking 2,000 kilowatts. It is not generating anything. It is up to them.
Mm-hmm.
And what I can do is whatever it is generating, I can get the net value, the amount it is been used, the amount the grid must require.
Mm-hmm.
And this part we can get from the renewable part and the conventional part.
Mm-hmm. Yeah. It makes sense, but you should also shape it in a better way. So let me explain a little bit different. Thank you very much.
Thank you.
Yeah. You are going to come here. Yeah. You can explain to us. Okay. Wow. Okay, so you have load, you have design, everything. Okay, rectifier, storage, EV. Yeah. It is the general model. Yeah. You said that we use a rectifier, charge the EV, and also we use the PV for DG. Yeah. Okay, thank you. Now this is the way we can do. Okay, but we it's like a mathematical model for the integration. But now the question was that how we can maximize the benefit for the community. Okay? But it's good. Thank you. So, again, get back the question. What is the how we can maximize the benefit? It's again this sugar and coffee. Why is like this one? Why is it like this one? And why? So it is not the complicated question. And the idea for asking this question is that you don't need to make everything complicated. Okay? So you should find the easiest solution. So we have loads, okay? So we have generation in community, okay? Then generation can be one from PV, all right? And from EV, yeah? Do we have something else? We have ESS, yeah? What? Balance condition? Power balance condition. No, now we are talking about, okay, so, but energy storage system, yeah. Then, what else we have? We have loads, yeah? Yeah, like, yeah, minus PL, okay? And then, this electric vehicle can be also considered as a load, okay? So, P electric vehicle in this is all charging, and this is charging. So, what else do we have? Energy storage can be also. Yeah, we put this one, yeah. And ESS also can be, okay? Yeah. So then, what else we have? So we have different types, actually, just a simple example. So what is the idea? Idea to reduce the stress over the grid, and this means that we have less dependency to the grid, okay? So then, if we reach to zero value, so it means that our consumption is equal to our generation. Yeah, even the best is that the positive is like this one. Okay? So, I don't care actually what is happening. But if we optimize this objective function, then we reach in the point that we have the best answer for the maximum profit. Okay? So what happens there? It means that it seems very simple, but then we should consider each one as an agent. This one, this one, this one, this one, this one, this one. Okay? So we don't know what happened when we reach in this objective function. What is happening when we are in charging or in the charging? And for the vehicle also the same. So you don't need to make something, okay, I do this one, that one, this one, that one, okay? So you should make it like a connection between generation and consumption, then optimize this one. And optimizing this one is not complicated things. Okay, you need some actually constraint and then run the program. So it's not that much complicated issue. So basically, I mean, we see that, you know, later that we optimize the system, and you see that it provides a very routine way, but we get the maximum actually benefit. So it's a something that, you know, nowadays we are working too much, but we make that one very complicated for ourselves. This is not something that, you know, make too much energy for that one and then reach that. We have some potential here. So we have the electric vehicle, we have charging station, we have PV, we have actually smart guys that control the loads. Then we reach the zero value for the objective function. Then it provides a balanced system for community and also independent from the grid. So in fact, by this optimization, we minimize the stress over the grid when the load is high, and also we minimize the payment from the community perspective to pay the distribution grid. In addition, by the tuning well, we see later how we can tune it. We see that, you know, we have a more reliable energy for our community. So in fact, we can somehow provide the stable operating condition without paying something. So the idea for this question was that, you know, next days we have actually some mathematical equation, again from the basic of the control of the converter, go to, I don't know, where we reach, okay? So thank you very much. Today is getting finished. Yeah, we see each other tomorrow.
Tomorrow we will share knowledge about reference frames.
The reference